Hello there, and welcome back to the channel. Tonight's journey takes us deep into the hidden corridors of the human mind, where thoughts form like constellations and memories drift like clouds across an endless sky. We'll explore 100 remarkable truths about psychology, each one a small window into the vast inner universe you carry with you always. Some of what we'll discover will feel familiar, like recognizing your own reflection in still water. Others will surprise you, revealing patterns and processes you never knew were shaping your experience of the world. You might find yourself drifting towards sleep as these ideas flow past, and that's perfectly fine. Let them wash over you gently, like waves on a distant shore. If you enjoy these quiet explorations, you can like and subscribe below and share your thoughts in the comments. But for now, all you need to do is settle in. Let your breathing slow, your body soften, and allow the wonder of your own mind to carry you wherever it will. Let's begin. Walking through a doorway can cause you to forget why you entered a room, and this isn't just absent-mindedness, it's a genuine quirk of how your brain organizes experience. Psychologists call this the doorway effect, and it occurs because your mind creates what are known as event boundaries. As you move from one space to another, your brain treats this transition as the end of one episode and the beginning of another, like chapters in a book. This compartmentalization normally helps you organize memories efficiently, keeping related information bundled together. But the side effect is that crossing a threshold can sometimes flush your working memory, leaving you standing in the kitchen wondering what you came for. Studies have shown this effect occurs both in physical environments and in virtual reality, suggesting it's not about the physical door itself, but about the mental shift it represents. The boundary signals your brain to file away the previous context and prepare for new information. Interestingly, walking back through the doorway often helps you remember as you're returning to the original event context. This reveals something profound about how deeply your mind is tied to the spaces you move through, weaving location and memory into a single fabric. When you try to remember a list of items, whether it's a grocery list or names at a party, you'll almost always recall the first and last items most clearly while the middle ones blur together. This remarkably consistent pattern is called the serial position effect, and it's been replicated in thousands of studies across cultures and age groups. The first items benefit from what's called the primacy effect. They receive more mental rehearsal because your working memory isn't yet crowded. You repeat them to yourself, consciously or not, embedding them more deeply into long-term storage. The last items enjoy the recency effect. They're still echoing in your short-term memory, fresh and accessible, not yet displaced by new information, but the items in the middle occupy a difficult position. They arrive after your attention has been divided and leave before they've had time to fully consolidate. They're caught in a kind of psychological twilight, neither fresh enough to remain in working memory nor rehearsed enough to have secured a place in long-term storage. This effect shapes more than just memory tests. It influences how we recall conversations, presentations, and even the flow of our days. The opening and closing moments shine brightest, while the middle, no matter how rich, often fades into a softer focus, reminding us that memory is as much about position as it is about importance. Your memories feel solid, like recordings of actual events, but research shows they're far more fragile and suggestible than you might imagine. In carefully designed studies, psychologists have successfully implanted entirely false memories in about 25% of participants, convincing them they experienced events that never happened. These aren't vague impressions. Subjects have recalled detailed memories of being lost in a shopping mall as a child, or meeting Bugs Bunny at Disneyland. Impossible, since Bugs Bunny is not a Disney character. The process typically involves repeated suggestions, exposure to doctored photographs, or hearing family members describe the fictional event. What makes this phenomenon so unsettling is that false memories don't feel different from real ones. They carry the same emotional weight, the same sensory details, the same sense of conviction. This happens because memory isn't a playback system, it's a reconstruction. Each time you remember something, your brain rebuilds it from fragments, filling gaps with plausible details, current knowledge, and suggestions from external sources. Over time, these reconstructed memories can drift far from their origins. This vulnerability has profound implications for eyewitness testimony, therapeutic memory recovery, and even how we understand our own life stories. The past, it turns out, is not a fixed country, but a landscape constantly being redrawn by the present, shaped as much by imagination as by truth. While you sleep, your brain is far from idle. It's engaged in the essential work of sorting, strengthening, and storing the memories you formed during the day. During certain sleep stages, particularly slow-wave sleep and REM sleep, neural patterns that were active during your waking experiences replay at accelerated speeds, like watching a recording on fast forward. This replay isn't random. Your brain is selectively strengthening important connections while allowing less relevant ones to fade. The hippocampus, which initially encodes new memories, communicates with the cortex, gradually transferring information into more permanent storage. Studies using brain imaging have captured this process in action, showing that the same neural pathways that fired when you learned something new reactivate during sleep, sometimes hundreds of times throughout the night. This consolidation doesn't just preserve memories, it reorganizes them, extracting patterns and integrating new information with existing knowledge. This is why sleep is so crucial for learning. Without it, memories remain fragile, easily disrupted, or lost entirely. Students who study and then sleep perform significantly better on tests than those who stay awake, even if the total time awake is the same. In this way, sleep is not a pause in consciousness, but a continuation of learning, a quiet workshop where the day's experiences are transformed into lasting knowledge, woven carefully into the growing tapestry of everything you know. You know the feeling. A word hovers just beyond reach, maddeningly close but stubbornly inaccessible. You can sense its shape, perhaps its first letter or how many syllables it contains, but the word itself won't come. Psychologists call this the tip of the tongue phenomenon, and it offers a fascinating glimpse into how your brain retrieves information. What's happening is a partial activation of the memory network. You've successfully accessed semantic information about the word, its meaning and context, but the phonological form, the actual sounds that make up the word, remains blocked. Often, similar sounding words will intrude, further jamming the retrieval process. This experience reveals that memory isn't stored as single, unified packages, but as distributed networks of related information, meaning sound, spelling, and usage are all stored in different regions, linked together through association. When one part of the network activates without the others, you're left with this peculiar feeling of knowing without quite knowing. Interestingly, tip-of-the-tongue states increase with age, not because memories themselves are necessarily weaker, but because the connections between different aspects of memory become slightly less efficient. The word almost always comes eventually, often when you stop trying and let your mind wander. This spontaneous retrieval suggests that the search process continues unconsciously, quietly sifting through possibilities until the right connection sparks and the word suddenly surfaces, bringing with it a small rush of relief. Your working memory, the mental space where you temporarily hold and manipulate information, has a surprisingly limited capacity. Most people can hold about 4 chunks of information at once, give or take 1 or 2 depending on the complexity. But here's where it gets interesting. A chunk can be a single digit, or it can be a meaningful group of items bundled together as a single unit. This process, called chunking, is one of the most powerful techniques for expanding your functional memory capacity. Instead of remembering 9 individual digits, you might chunk a phone number into 3 groups. Instead of memorizing random letters, you might notice they spell words. Expert chess players use chunking to remember entire board positions. They don't memorize individual piece locations, but instead recognize familiar patterns, configurations they've seen before, allowing them to encode a complex arrangement as a single chunk. The same principle applies to music, language, and virtually any domain of expertise. What looks like an overwhelming flood of information to a novice becomes a manageable collection of meaningful patterns to an expert. This transformation happens gradually as you learn. Your brain automatically begins grouping related elements together, creating larger and more efficient units of thought. Chunking reveals something beautiful about learning. As you gain expertise, you're not just accumulating more information, you're fundamentally reorganizing how you think, building larger mental structures that let you work with increasing complexity while feeling less overwhelmed. Emotionally charged experiences sear themselves into memory with remarkable clarity. You likely remember exactly where you were during significant personal moments or major historical events, the sensory details vivid even years later. This happens because emotion and memory are deeply intertwined in your brain's architecture. When you experience something with strong emotional content, whether joy, fear, surprise, or sadness, the amygdala becomes highly active. This almond-shaped structure sits adjacent to the hippocampus, the brain's memory-forming center, and when activated, the amygdala essentially tells the hippocampus, "This matters. Remember this." The result is enhanced encoding. The neural connections representing that memory are strengthened, the details are given priority, and the experience is marked as significant. This system evolved for good reason. Remembering emotionally important events, especially threatening ones, provided a survival advantage. If you narrowly escaped danger, you needed to remember the circumstances clearly to avoid similar situations. In modern life, this means your strongest memories are often tied to your strongest feelings. A first kiss, a moment of loss, a triumph, or a humiliation. These experiences occupy privileged space in your mental archives. However, there's a fascinating nuance. While emotion enhances memory for the central details of an event, it can actually impair memory for peripheral information. Your attention narrows, focusing on the source of emotion while the surrounding context fades, leaving you with a spotlight memory, brilliant at the center but dim at the edges. If you want to truly learn something, one of the most effective strategies isn't reviewing the material again but testing yourself on it. This finding, replicated across hundreds of studies, is called the testing effect or retrieval practice. When you attempt to recall information from memory, you're not just checking what you know, you're actively strengthening the neural pathways that store that knowledge. Each successful retrieval makes the memory more accessible in the future, like wearing a path through tall grass. The effort of retrieval itself, even when difficult, creates stronger learning than passive review. This works even when you make mistakes during testing. The act of searching through memory, considering possibilities and generating answers engages deeper processing than simply reading the same information again. Students who spend time testing themselves, whether through flashcards, practice problems, or simply trying to write out everything they remember, consistently outperform those who spend the same amount of time rereading their notes. The difference can be dramatic, often improving retention by 50% or more. What makes this particularly valuable is that it works against your intuition. Rereading feels productive because the material becomes familiar, creating an illusion of learning. Testing feels harder, more uncomfortable, because it exposes what you don't yet know. But that discomfort is precisely where learning happens. In the struggle to retrieve, the brain builds the connections that make knowledge lasting and accessible. Unfinished tasks have a peculiar way of lingering in your mind, intruding on your thoughts far more persistently than tasks you've completed. This phenomenon is called the Zeigarnik effect, named after psychologist Bluma Zeigarnik, who first documented it in the 1920s. The story goes that she noticed waiters could remember complex orders perfectly while they were in progress, but once the bill was paid and the table cleared, the details vanished from their memory almost immediately. The uncompleted task created a kind of cognitive tension, a mental open loop that kept the information active and accessible. This effect extends throughout daily life. An unfinished conversation keeps replaying in your mind. An interrupted project pulls at your attention even when you're doing something else. Your brain treats incomplete goals as active concerns, maintaining them in a more accessible state than finished business. While this can be a source of stress, it also reveals an important truth about motivation. The mind naturally seeks completion and closure. This is why creating a to-do list can feel so calming even before you've completed any tasks. Writing down what needs doing signals to your brain that the task is accounted for, partially closing that cognitive loop. The Zeigarnik effect also explains why cliffhangers in stories are so effective. The unresolved narrative creates tension that the mind wants to resolve, pulling you back to find out what happens next. In your own life, this principle suggests that sometimes the best way to clear your mind isn't to finish everything, but simply to capture your commitments in a trusted system, allowing your thoughts to finally rest. When people talk about muscle memory, they're describing a real phenomenon, though the name is somewhat misleading. Your muscles themselves don't store memories. Instead, repeated physical movements are encoded in your brain, particularly in the cerebellum and motor cortex. These regions learn sequences of movements through practice, gradually refining and automating them until they can be performed with little conscious thought. When you first learn a physical skill, whether typing, playing an instrument, or riding a bicycle, each movement requires deliberate attention. Your conscious mind must direct every action, making the process slow and effortful. But with repetition, something remarkable happens. The neural pathways controlling those movements become increasingly efficient, the connections strengthen, and the sequence becomes chunked into larger, automatic units. What once required conscious control now flows smoothly without deliberate thought. This is why you can type without looking at the keyboard, or why a pianist's fingers can fly across keys while their mind focuses on expression rather than individual notes. The cerebellum plays a crucial role in this transformation, fine-tuning timing and coordination, storing the precise patterns of activation needed for smooth, skilled movement. Once established, these motor memories are remarkably durable. Skills learned in childhood, even if neglected for decades, often come back quickly with practice. The neural pathways may weaken from disuse, but they don't disappear entirely. This persistence explains the old saying that you never forget how to ride a bike. The pattern remains encoded, waiting patiently in your cerebellum for the chance to express itself once more. One of the most robust findings in all of learning science is the spacing effect. Information studied over multiple sessions separated by time is retained far better than information crammed into a single marathon session. The improvement isn't small. Distributed practice can lead to dramatically better long-term retention compared to massed practice. Yet students consistently underestimate this advantage, often choosing to cram because it feels more efficient in the moment. The material becomes familiar quickly during a cramming session, creating an illusion of mastery that doesn't actually reflect durable learning. Spaced repetition works because each time you return to material after a delay, you're forced to retrieve it from memory, and that retrieval effort strengthens the underlying connections. Additionally, spacing allows time for consolidation, the process by which memories stabilize and become integrated with existing knowledge. When you encounter material multiple times over days or weeks, your brain has opportunities to process it during sleep, to connect it with other information, and to build a richer, more interconnected understanding. The optimal spacing depends on how long you need to remember something. For an exam weeks away, reviewing every few days works well. For knowledge you want to retain for years, spacing reviews over months creates the most durable memory. This principle applies far beyond academic learning. Any skill or knowledge you wish to maintain benefits from regular spaced practice rather than occasional intensive bursts. The spacing effect reveals a fundamental truth about memory. Repetition matters less than you think, timing matters more than you realize, and patience, counterintuitively, is the fastest path to lasting knowledge. Every time you remember something, you're not simply accessing a stored file. You're reconstructing that memory from distributed components, and in the process, you make it vulnerable to change. This process is called reconsolidation, and it means that memories aren't fixed archives, but living, malleable constructs that can be altered each time they're recalled. When you retrieve a memory, it enters a temporarily unstable state for several hours before restabilizing. During this window, new information can be incorporated, details can shift, and the emotional tone can be modified. This reconsolidation process has profound implications. It means that your memories of important life events may have drifted from their original form, subtly reshaped by subsequent experiences, current emotions, and the act of retelling. Each time you share a story, you're not just reporting the past, you're potentially rewriting it. This isn't necessarily a flaw, it may be a feature. Reconsolidation allows memories to remain relevant and useful rather than being frozen in outdated forms. It lets you integrate new understanding with old experiences, updating your personal history as you grow and change. Researchers are exploring therapeutic applications of reconsolidation, using the window of instability to reduce the emotional intensity of traumatic memories or to correct problematic associations. By bringing a memory to mind and then introducing new, contradictory information during the reconsolidation window, it may be possible to update memories in ways that promote healing. This research reminds us that the past, as we remember it, is not fixed but fluid, a story continuously being written in the present moment. Where you learn something matters more than you might think. Memory is not just about content, it's also about context, the surrounding environment, your physical state, and even your mood when the memory forms. This is called context-dependent memory, and it means you'll often recall information better when you're in the same environment where you learned it. Students who study in the same room where they'll take an exam often perform better than those who study elsewhere, not because the room itself contains answers, but because environmental cues present during learning become woven into the memory, serving as retrieval aids. This effect has been demonstrated in dramatic ways. In one famous study, scuba divers who learned words underwater recalled them better when tested underwater than on land, and vice versa. The underwater environment, so unusual and distinctive, became part of the memory structure itself. The same principle applies to less extreme situations. The smell of a particular room, the ambient noise, the lighting, even the time of day, all these elements can become associated with what you're learning, creating multiple pathways back to that information. Understanding context dependency can make you a more effective learner. If you'll need to recall information in various settings, studying in multiple different environments can actually help. It prevents the memory from becoming too dependent on any single context. Alternatively, if you know where you'll need the information, practicing retrieval in that specific environment can strengthen the connection. Your memory, it turns out, extends beyond your skull, reaching out into the world around you, embedding itself in the spaces and moments where learning happens. Just as the external environment can serve as a memory cue, so too can your internal state. State-dependent memory means that what you learn in a particular mood, level of alertness, or even level of intoxication is often recalled more easily when you return to that same state. This doesn't mean you should study while tired or intoxicated. Being in an impaired state generally makes learning worse overall. But it does mean that the physiological and emotional context of learning becomes part of the memory trace. This phenomenon has been observed across various dimensions of internal state. Information learned while happy is somewhat easier to recall when you're happy again. Material studied while caffeinated may be slightly more accessible when you're caffeinated. Even your posture can matter. Memories formed while standing may be marginally easier to retrieve while standing. These effects are typically subtle, not dramatic shifts, but they accumulate and interact in complex ways. They reveal that memory is deeply embodied, not an abstract mental filing system, but a process intimately connected to your entire physical and emotional experience. State dependency can work against you in stressful situations. If you've only ever practiced a skill in calm, comfortable conditions, performing under pressure may feel more difficult because your internal state has changed. This is why exposure to varied conditions during practice, including stress, can improve performance when it matters. Your memories are not stored in a vacuum, they're embedded in the full context of your being, shaped by mood, alertness, and the countless subtle variations in how you feel from moment to moment, making you and your memories inseparable. Information that you generate yourself through effort and active processing is remembered far better than information you passively receive. This is called the generation effect, and it's one of the reasons why teaching is such a powerful learning tool. When you're forced to produce an answer, complete a sentence, or explain a concept in your own words, you engage more deeply with the material. You must search your existing knowledge, make connections, and construct meaning rather than simply receiving it pre-packaged. The effort matters. Struggling to generate an answer, even if you initially fail, creates a richer mental context than having the answer simply presented. This is why fill-in-the-blank exercises often produce better learning than multiple choice, why solving problems is more effective than watching someone else solve them, and why attempting to recall information before looking it up strengthens memory more than immediate verification. Each act of generation requires you to actively manipulate information, leaving deeper traces in memory than passive exposure ever could. This principle suggests a powerful approach to learning. Rather than reading material multiple times, Try to generate the key ideas from memory after a single reading. Write summaries without looking at the text. Explain concepts to others or to yourself. Ask questions and attempt to answer them before checking. These active, generative processes feel more difficult than passive review, and that difficulty is precisely what makes them effective. Learning happens not in the comfort of recognition, but in the productive struggle of generation, where your mind works to create rather than merely consume, transforming information into knowledge that truly becomes your own. Your vision feels complete and seamless, a continuous picture of the world before you. But this completeness is partly an illusion, carefully constructed by your brain. You have a blind spot in each eye where the optic nerve exits the retina, a region with no photoreceptors to detect light. You never notice this gap because your brain fills it in automatically, using information from the surrounding area and from the other eye. But the filling in process goes far beyond just the blind spot. Your brain constantly interpolates, smooths, and invents visual information to create a coherent experience. This happens in countless subtle ways. When you blink, your brain edits out the darkness, creating the illusion of continuous vision. In your peripheral vision, where detail is sparse, your brain fills in patterns based on expectations. Even your central vision contains gaps and ambiguities that are resolved through predictive processing, your brain using past experience to guess what's most likely there. This constructive process usually works seamlessly, but occasionally it reveals itself. Optical illusions often exploit these filling-in mechanisms, creating situations where your brain's predictions diverge from reality. Understanding that you don't see the world directly, but rather see your brain's reconstruction of it, can be both unsettling and liberating. It means that perception is always an interpretation, a best guess based on limited information. Every moment, your visual experience is being actively created, a collaboration between light entering your eyes and the vast machinery of prediction and inference running continuously in your visual cortex, painting a picture of the world that feels objective but is deeply, inescapably subjective. What you see can dramatically change what you hear, even when you know it's happening. The McGurk effect is a striking demonstration of this multi-sensory integration. In the classic demonstration, you watch a video of someone mouthing one syllable, like gar, while the audio plays a different syllable, like bar. Remarkably, most people perceive a third sound entirely, often dar, a fusion of the visual and auditory information. Even when you know about the trick, even when you close your eyes and clearly hear bar, opening them again usually brings back the illusion. This effect reveals that perception isn't organized by sense. Hearing stays with hearing, vision with vision. Instead, your brain combines inputs from multiple senses before conscious perception, creating unified experiences. Speech perception particularly benefits from this integration. Watching someone's lips move helps you understand them in noisy environments, not just by providing redundant information, but by actually changing what you hear. Your brain has learned that these different streams of information, auditory and visual, usually refer to the same event, so it fuses them automatically. The McGurk effect demonstrates something profound about the nature of reality as you experience it. There is no pure, unfiltered sensation reaching your awareness. Every perception is a constructed interpretation, blending multiple sources of information according to rules learned through experience. Your senses don't report the world to you. They collaborate to build a working model of it, and that model, convincing as it feels, is always an intelligent guess, a brain's best story about what's happening beyond the boundaries of your skull. Walk into your own home after being away, and you might notice its particular smell, but within minutes, that scent vanishes from your awareness. This isn't because the odor has dissipated, it's because your sensory neurons have adapted. Sensory adaptation is a fundamental feature of how your nervous system works. When a stimulus remains constant, your sensory receptors gradually reduce their firing rate, and your brain begins to filter out the unchanging signal. This makes perfect sense from an efficiency standpoint. Constant information provides little useful data. It's the changes, the contrasts, that matter for navigating the world. This adaptation happens across all your senses. You stop feeling your clothes minutes after putting them on. A constant background hum becomes inaudible. A persistent visual pattern fades from awareness. Your sensory systems are designed to detect change, not to continuously report stable conditions. This is generally helpful, freeing up neural resources for new and potentially important information. But it also means you're constantly missing aspects of your environment that have become too familiar to notice. The sound of your own breathing, the feeling of your tongue in your mouth, the blind spot in your vision, all these are edited out of conscious experience. Nose blindness to your own home's smell is perhaps the most recognizable example of this process. It's why you might not notice an odor that's obvious to visitors, and why returning after time away brings a fresh perspective. The adaptation resets, allowing you to temporarily perceive what had become invisible before the familiar fades once again into the background, filtered out by a brain that's always seeking the new. For most people, the senses operate in separate channels. Sounds are heard, colors are seen, textures are felt. But for about 4% of the population, these boundaries blur in fascinating ways. People with synesthesia experience automatic, involuntary connections between different sensory modalities. A musical note might trigger the perception of a specific color, a written number might carry an inherent personality or gender. A particular taste might evoke a geometric shape. These aren't metaphors or associations, they're genuine perceptual experiences, as real to a synesthete as any ordinary sensation. The most common form is grapheme color synesthesia, where letters or numbers are experienced as inherently colored. For someone with this form, the letter A might always appear tinged with red. The number 5 might carry a greenish hue. These associations are highly specific and remain consistent over a lifetime. Brain imaging suggests synesthesia arises from increased connectivity between brain regions that normally process different types of information. In most brains, these regions communicate but maintain distinct processing streams. In synesthetes, the boundaries are more porous, leading to experiences that blend senses in unusual ways. Synesthesia reminds us that there's no single way to experience reality. The same world can appear vastly different depending on how your brain is wired. For synesthetes, music isn't just heard but seen and felt. Numbers aren't abstract but colorful and characteristic. Their perceptual world is richer with cross-sensory connections, a reminder that consciousness itself is not uniform but varies in subtle and profound ways across individuals, each mind constructing its own private version of reality from the raw material of sensation. Your pupils don't just respond to light, they also betray your inner state. When you're excited, interested, or attracted to something or someone, your pupils dilate, growing larger even if the lighting hasn't changed. This happens because pupil size is controlled partly by the autonomic nervous system, the same system that regulates heart rate and stress responses. Emotional arousal, whether positive or negative, triggers pupil dilation. Psychologists have used this as an indirect measure of interest and attraction for decades, since pupil size is difficult to consciously control. This response is subtle. You won't notice it casually, but it's detectable in close conversation or in careful observation. Some research suggests people unconsciously register others' pupil size and find dilated pupils more attractive, perhaps because they signal interest and engagement. Advertisers and photographers have long known this, sometimes artificially enhancing pupil size in images to make subjects appear more appealing. The connection between pupils and emotion runs deep, rooted in the body's preparation for action. Dilated pupils allow more light in, potentially improving vision in moments of heightened arousal when you might need to see more clearly. Interestingly, cognitive effort also causes pupils to dilate. When you're working on a difficult mental task, your pupils expand in proportion to the difficulty, growing largest when you're at the edge of your cognitive capacity. This means that pupil size provides a real-time window into mental effort and emotional state, a tiny physical signal broadcasting information that you might prefer to keep hidden. Another reminder that your body constantly expresses what your words might not, speaking its own honest language in micro-movements and physiological shifts that ripple through every moment. Place a rubber hand on a table in front of you while your real hand is hidden from view. Have someone simultaneously stroke both the rubber hand and your hidden real hand with a brush. Within minutes, something strange happens. You begin to feel as though the rubber hand is your own. When someone threatens the rubber hand with a knife, you'll flinch. Your brain has been tricked into incorporating this foreign object into your body schema. This illusion reveals how your sense of bodily self is constructed through multisensory integration. Your brain uses vision, touch, and proprioception to maintain a model of your body's boundaries. When these signals align consistently, even if one source is false, your brain accepts the combined input as reality. The rubber hand illusion demonstrates that body ownership is not fixed, but remarkably flexible, constantly being recalibrated based on available sensory evidence. This malleability serves you well normally, allowing adaptation to growth, injury, or tool use. But it also shows that your most intimate sense of self, the feeling of inhabiting your own body, is a construction that can be manipulated, questioned, and temporarily revised by carefully arranged sensory experiences. Your sense of smell operates through a remarkably sophisticated system. Odor molecules bind to hundreds of different receptor types in your nose, each sensitive to particular molecular features. The combination of activated receptors creates a pattern, a signature that your brain interprets as a specific smell. This combinatorial system allows you to distinguish an extraordinary range of odors, far more than the often cited 10,000 smells limit suggested by older research. Recent estimates place the number much higher, though the exact figure remains debated. What makes smell particularly powerful is its direct connection to the limbic system, the brain's emotional center. Olfactory information travels to the amygdala and hippocampus with fewer intermediate processing steps than other senses. This is why smells can trigger vivid memories and strong emotions so immediately and involuntarily. A whiff of perfume can transport you instantly to a moment decades past, complete with emotional resonance. This ancient sense, often undervalued in modern life, carries information that bypasses rational processing, speaking directly to memory and emotion in a language older than words. Your brain distinguishes between reading about pain and actually feeling it, but the overlap between these experiences is surprisingly large. When you read words like excruciating or agonizing, or when you watch someone else get injured, regions of your pain matrix become active. These include the anterior cingulate cortex and insula, areas involved in the emotional and evaluative aspects of pain. However, the primary somatosensory cortex, which processes the physical location and intensity of pain, typically activates only during actual painful experiences. This partial overlap explains why observing or imagining pain can be genuinely uncomfortable. Your brain simulates others' pain to help you understand and empathize with their experience. This simulation isn't as intense as real pain, but it's neurologically real, not merely metaphorical. The system likely evolved to help us learn from others' misfortunes without having to experience every danger firsthand. When you wince at someone else's injury, your brain is running a muted version of what that pain might feel like, using your own pain memories as reference, creating empathy through shared neural architecture. After losing a limb, up to 80% of amputees experience phantom sensations, feeling touch, movement, or pain in the absent body part. This occurs because the brain's body map, a representation of your physical form laid out across the somatosensory cortex, doesn't immediately update when a limb is removed. The neural territory that once received input from the missing limb remains, and in the absence of actual signals, it can generate spontaneous activity that's interpreted as sensation from the phantom limb. Sometimes neighboring regions begin to invade this unused territory. Touching the face might trigger sensations in a phantom hand because the face's representation sits adjacent to the hands in the cortical map. This reorganization demonstrates neuroplasticity, but it can also create problems, particularly phantom pain. Some treatments exploit this plasticity creatively. Mirror therapy, where amputees watch their intact limb in a mirror positioned to look like the missing one, can reduce phantom pain by providing visual feedback that helps resolve conflicts in the brain's body representation. These phantom experiences remind us that your sense of your body exists first in your brain, a mental model that can persist even when the physical reality has changed. Try this. Look at the word red printed in blue ink and say aloud the color of the ink, not the word itself. You'll find this surprisingly difficult. Your reading is so automatic, so deeply ingrained that it interferes with the seemingly simpler task of naming colors. This is the Stroop effect, one of psychology's most reliable phenomena. The interference occurs because reading happens automatically and rapidly, while color naming requires more deliberate processing. When these processes conflict, your brain must inhibit the automatic response to access the controlled one. The Stroop effect reveals that automaticity comes at a cost. Skills you've practiced extensively become fast and effortless, but also difficult to suppress. This is generally advantageous, freeing mental resources for other tasks. But in situations where automatic responses conflict with your goals, that same automaticity creates interference. The effect has become a valuable tool for studying attention, cognitive control, and the balance between automatic and deliberate processing. It demonstrates that your mind is not a unified executive smoothly directing all operations, but rather a collection of systems, some automatic and some controlled, sometimes working together harmoniously and sometimes competing for influence. Time feels elastic, stretching and compressing based on your experience. When you're deeply engaged in something enjoyable, hours can vanish in what feels like minutes. Conversely, boredom makes time crawl. This variability occurs because time perception depends partly on how much attention you pay to time itself. When you're absorbed in an activity, you're not monitoring the passage of time, and retrospectively, the period seems to have passed quickly. However, if you check the clock repeatedly, each moment becomes marked and measured, making duration feel longer. There's also a curious asymmetry between experiencing time and remembering it. An enjoyable vacation might fly by while you're there but seem long when you remember it later, because it was filled with novel, memorable experiences. A boring afternoon drags while happening but leaves little memory trace, seeming brief in retrospect. This is why routine makes life feel like it's accelerating. Days blur together without distinct memories, while novelty and engagement, though passing quickly in the moment, create a richer sense of lived time when you look back, reminding you that how you spend time shapes not just experience, but memory. Your attention is far more selective than you realize. In a famous experiment, participants watched a video of people passing basketballs and were asked to count the passes. About half of viewers completely failed to notice a person in a gorilla suit walking through the scene, stopping to beat their chest before exiting. This dramatic failure of awareness, called inattentional blindness, reveals that you don't see everything before your eyes. You see what you're paying attention to. Your visual system gathers enormous amounts of information, but your conscious awareness can only handle a small fraction at any moment. Attention acts as a filter, selecting what reaches consciousness while the rest, though technically visible, goes unnoticed. This isn't a flaw, but a necessary feature of a system with limited processing capacity. In daily life, inattentional blindness means you routinely miss unexpected events, even obvious ones, when your attention is focused elsewhere. The gorilla demonstrates something humbling. You can look directly at something and not see it at all if your mind is engaged with a different task, a reminder that seeing is not passive reception but active construction, and what you construct depends entirely on where you direct your limited attention. Your brain is remarkably fast at detecting faces. Within about 170 milliseconds of seeing an image, specialized neural machinery has already determined whether a face is present. This rapid detection happens in the fusiform face area and related regions, which have evolved or developed to prioritize this crucial social stimulus. Faces provide vital information about identity, emotion, direction of attention, and intent, making fast, accurate face detection evolutionarily valuable. This specialized processing is so sensitive that it triggers even for face-like patterns, which is why you see faces in clouds, electrical outlets, or the front of cars. Your brain is biased toward finding faces, erring on the side of false positives rather than missing a real one. This makes sense from a survival perspective. Mistaking a pattern for a face costs little, but failing to detect an actual face could mean missing social information or overlooking a threat. The speed and sensitivity of face detection demonstrate how your brain prioritizes social information, automatically and continuously scanning your environment for these uniquely important stimuli, ready within a fraction of a second to begin the complex process of recognition, emotion reading, and social cognition. The relationship between expression and emotion flows in both directions. You smile because you're happy, but smiling can also make you happier. This is the facial feedback hypothesis. Your facial muscles send signals to your brain that influence emotional experience. When you hold a smile, even artificially, your brain receives feedback indicating positive emotion and responds accordingly, releasing neurotransmitters associated with happiness. The effect is subtle but measurable, not a cure for sadness, but a gentle nudge toward more positive mood. Research has shown this works with other expressions too. Frowning can intensify negative emotions, while relaxing facial tension can reduce them. Some studies have found that people unable to frown due to Botox injections report fewer negative emotions, though this research remains somewhat controversial. The broader principle that body and mind influence each other bidirectionally is well established. Your physical state shapes your mental state, and vice versa, in a continuous feedback loop. This suggests that managing your physical expression, posture, and movement isn't just about appearing a certain way to others. It's also about communicating with your own brain, using your body to influence your mind from the outside in. Crying isn't just emotional release, it's biochemical. When you cry, particularly during emotional crying as opposed to tearing from irritants, your body releases oxytocin and endorphins. These natural chemicals act as pain relievers and mood improvers, which explains why many people feel calmer and better after a good cry, even though the problem that caused the tears hasn't changed. The physical act of crying appears to activate the parasympathetic nervous system, helping your body return to a calmer state after emotional arousal. Emotional tears also have a different chemical composition than reflex tears, containing more protein and stress hormones. Some researchers theorize that crying may serve to physically excrete stress-related chemicals from the body, though this remains debated. What's clear is that crying serves multiple functions. It signals distress to others, potentially eliciting support, and it helps regulate your own emotional state through both chemical release and the physical experience of letting go. Suppressing tears, conversely, maintains tension and prevents this natural regulatory process. In this way, crying is not weakness but a sophisticated emotional regulation mechanism, one that works through your body to soothe your mind, offering relief that comes not from solving problems but from allowing feelings their full expression. Emotions spread between people like invisible currents. When you're around someone who's anxious, you tend to become anxious. Joy, anger, fear, all these states transfer through a process called emotional contagion. This happens largely through mirror neurons and automatic mimicry. You unconsciously mirror others' facial expressions, posture, and tone of voice, and this physical mimicry creates corresponding emotional states in your own body through the same feedback mechanisms that link your own expressions to your feelings. Emotional contagion serves social functions, helping groups coordinate their emotional states and responses. It builds empathy and social bonds, allowing you to resonate with others' experiences. But it also means you're constantly influenced by the emotional climate around you, absorbing stress from tense colleagues or uplift from cheerful friends. This effect is stronger with people you're close to and can operate below conscious awareness. You might leave a conversation feeling drained or energized without quite knowing why, having caught the other person's emotional state like a subtle infection. Understanding emotional contagion helps you recognize that your feelings aren't always entirely your own, but are shaped continuously by your social environment, spreading through networks of connection in waves you rarely notice but constantly experience. You might imagine that winning the lottery would permanently increase your happiness, or that a major setback would leave you perpetually unhappy. But research on the hedonic treadmill suggests otherwise. This phenomenon describes your tendency to return to a relatively stable baseline level of happiness despite major positive or negative life changes. Lottery winners experience an initial surge of happiness that fades over time as they adapt to their new circumstances. Similarly, people who experience serious setbacks, even major ones, often return closer to their baseline happiness levels than you might expect. This adaptation occurs because your happiness depends largely on changes and contrasts rather than absolute conditions. What's novel and surprising today becomes routine tomorrow, losing its emotional impact. Your expectations adjust to match your circumstances, constantly recalibrating what feels good or bad. This isn't to say major life events don't matter. They do, especially events affecting social relationships, health, and autonomy. But the hedonic treadmill suggests that pursuing happiness through external circumstances alone often leads to disappointment. The new job, house, or relationship brings temporary joy before adaptation sets in. Lasting well-being seems to come more from how you engage with life, your relationships, sense of purpose, and internal practices than from achieving particular external conditions. Writing about traumatic or emotionally difficult experiences can improve physical health in measurable ways. Studies have found that people who spend 15 to 20 minutes writing about their deepest thoughts and feelings regarding difficult experiences show improved immune function, reduced doctor visits, and better overall health compared to those who write about superficial topics. The benefits appear weeks or months after the writing sessions end, suggesting real physiological changes rather than temporary mood effects. The mechanism isn't entirely clear, but expressive writing seems to help organize and make sense of difficult experiences, reducing the cognitive work required to suppress or avoid them. Inhibiting thoughts and feelings requires effort that may create stress and tax the body over time. By translating experience into language, you may process emotions more completely, reducing their lingering physical impact. The writing doesn't need to be beautiful or grammatically perfect. What matters is honesty and engagement with difficult material. This research suggests that emotional and physical health are deeply intertwined, and that practices helping you process and integrate difficult emotions don't just improve mental well-being, but can actually strengthen your body's defenses and resilience. Music can give you chills, make you weep, or fill you with energy, and these responses have a neurochemical basis. Listening to music, you find moving triggers, dopamine release in your brain's reward system, the same system activated by food, sex, and other primary pleasures. Brain imaging studies have shown that dopamine levels spike during particularly pleasurable moments in music, often right before an anticipated climax or during an unexpected musical turn. Interestingly, the anticipation of these musical moments can be as pleasurable as the moments themselves, with dopamine release building as you approach a satisfying resolution. This explains why familiar songs remain enjoyable. You anticipate the emotional payoff even when you know it's coming. Music's power to affect emotion likely relates to its abstract nature and temporal structure. It unfolds over time, creating patterns of tension and release that engage prediction systems in your brain. When predictions are confirmed or pleasantly violated, the reward system responds. This deep connection between music and emotion explains why music has been central to human culture across all societies. It directly accesses neural systems designed to signal value, importance, and pleasure, making it universally powerful and personally meaningful. Your brain is more responsive to negative information than positive. Bad news grabs your attention more effectively than good news. A criticism stings more and lingers longer than a compliment feels good. This negativity bias appears throughout cognition. Negative events are processed more thoroughly, weighted more heavily in decisions, and remembered more clearly than equivalent positive events. From an evolutionary perspective, this makes sense. Missing a potential threat could be fatal, while missing an opportunity might simply mean a lost chance among many. The cost of this ancient bias in modern life is that you may systematically overestimate dangers and underappreciate positives. News media exploit this bias, knowing that threatening or upsetting content attracts more attention. In relationships, it takes multiple positive interactions to balance one negative one. The negativity bias contributes to anxiety, pessimism, and difficulty savoring good experiences as your attention automatically gravitates toward what's wrong. Understanding this bias won't eliminate it. It's deeply embedded in how your brain works, but awareness allows you to consciously counterbalance it, deliberately attending to positive information, practicing gratitude, and recognizing that your spontaneous sense of threat level is likely overestimated. Your brain is designed to keep you safe, not happy, and sometimes compensating for that design serves you better than simply trusting your automatic responses. Deliberately cultivating gratitude through regular practices can measurably increase happiness and life satisfaction. Studies have found that people who keep gratitude journals, writing down things they're thankful for several times a week, report higher levels of well-being, better sleep, and even more exercise compared to control groups. The effects develop over weeks of practice, suggesting that gratitude training gradually reshapes attention and interpretation patterns rather than providing just temporary mood boosts. Gratitude works partly by shifting focus from what's missing to what's present, from problems to sources of support and value. This shift isn't about denying difficulties, but about achieving a more balanced perspective that includes appreciation alongside awareness of challenges. Neurologically, gratitude activates brain regions associated with social bonding and reward, creating positive feedback loops that make grateful thinking more accessible over time. The practice is simple but not always easy, especially when facing real hardship. Yet even in difficult circumstances, finding small things to appreciate, a kind gesture, a moment of beauty, basic comforts, can provide psychological ballast. Gratitude doesn't solve problems, but it changes your relationship to your experience, helping you notice the good that exists alongside the difficult, creating a more complete and often more bearable picture of your life. Physical warmth and social warmth overlap in your brain in surprising ways. Studies have shown that holding a warm cup of coffee makes people judge others as more generous and caring, while cold temperatures increase feelings of loneliness. The connection runs deep. Areas like the insular process both physical temperature and social feelings of warmth or coldness. This overlap likely arose because temperature regulation and social bonding both relate to survival and comfort, particularly in infancy when warmth comes primarily from caregivers. The metaphor of warm feelings or a cold shoulder turns out to have neurological reality. Your brain doesn't maintain completely separate systems for physical and emotional experience, but instead reuses neural architecture across domains. This explains why warming your hands can make you feel more positively toward others, and why social rejection can feel physically cold. The connection suggests that comfort in its various forms shares common neural pathways. A warm environment, a warm touch, warm social interactions, all these create overlapping signals of safety and well-being. This interweaving of physical and social experience reminds you that emotional life is deeply embodied, that feelings are not purely mental but involve the whole body, temperature included, in creating your sense of security and connection. The relationship between anxiety and performance follows an inverted U-shaped curve, often called the Yerkes-Dodson law. Too little arousal and you're unmotivated and unfocused. Too much anxiety and you're overwhelmed, with performance degrading. But moderate anxiety right in the middle can actually enhance performance, particularly on well-learned tasks. This optimal anxiety sharpens attention, increases motivation, and mobilizes resources without overwhelming your cognitive capacity. The key is that anxiety's effect depends on task complexity and your skill level. For simple or well-practiced tasks, higher arousal can help, energizing you without causing problems. For complex or unfamiliar tasks, even moderate anxiety can impair performance by consuming working memory and disrupting flexible thinking. This explains why athletes often perform best with some nervousness. The arousal enhances their practiced skills. But students taking tests on new material may perform worse when very anxious, as worry intrudes on the cognitive resources needed for problem solving. Understanding this curve helps you interpret your own anxiety more accurately. Some nervousness before a challenge isn't always bad. It might be your body preparing you to perform. The goal isn't to eliminate all anxiety, but to find the level that energizes rather than overwhelms, recognizing that a certain amount of nervous energy is part of optimal performance. Positive emotions don't just feel good, they change how you think. According to the broaden and build theory, positive emotions like joy, interest, and contentment expand your attention and thinking patterns. While negative emotions narrow focus to specific problems or threats, positive emotions open you to wider possibilities, making you more creative, more likely to notice peripheral information, and more flexible in problem solving. This broadening helps you build resources, learning new skills, forming social connections, and developing coping strategies that serve you beyond the immediate moment. Research supports this pattern. People in positive moods perform better on tasks requiring creativity and flexible thinking. They're more likely to see connections between disparate ideas and to consider multiple solutions. This expansion is adaptive. When things are going well and no immediate threat demands attention, broadening your perspective helps you grow and prepare for future challenges. The theory suggests that cultivating positive emotions isn't just about feeling good, it's about creating the mental conditions for learning and growth. Small positive experiences, moments of gratitude, play, or connection accumulate over time, gradually building psychological resilience and cognitive flexibility. In this view, positive emotions are not merely pleasant states, but tools for expanding your capabilities, seeds that grow into future strengths. Nostalgia, that bittersweet longing for the past, serves surprising psychological functions. Rather than being merely sentimental, nostalgia actually helps maintain well-being. Research shows that nostalgic reflection increases feelings of social connectedness, reduces loneliness, boosts self-esteem, and creates optimism about the future. When you're feeling isolated or uncertain, reminiscing about meaningful past experiences reminds you of enduring bonds and your capacity to navigate challenges, providing psychological comfort and continuity. Nostalgia peaks during transitional periods and when you're feeling down, suggesting it functions as a regulatory mechanism. By reconnecting with your past self and relationships, you reinforce your sense of identity and belonging. The memories tend to be selective, focusing on meaningful positive experiences while softening difficulties, creating a reassuring narrative of your life. While excessive nostalgia can become problematic if it prevents engagement with the present, moderate nostalgic reflection appears healthy and restorative. It links your past, present, and future into a coherent story, reminding you that you've weathered changes before and maintained important connections across time. In this way, nostalgia isn't escape from reality, but a resource drawn from memory, a way of carrying forward what matters most as you continue through life's changes. Laughter does more than signal amusement, it actually changes your body's pain processing. Studies have shown that laughing increases pain tolerance, allowing people to withstand discomfort longer after a period of genuine laughter. This effect occurs because laughter triggers the release of endorphins, the body's natural painkillers. These neurochemicals bind to opioid receptors in the brain, reducing pain perception and creating feelings of well-being. The laughter must be genuine and sustained to produce the effect. Polite chuckling doesn't generate the same endorphin response. Interestingly, shared laughter in groups produces stronger effects than laughing alone, perhaps because social bonding itself triggers additional neurochemical responses. This pain-reducing quality of laughter may be one reason humor has been universal across human cultures. It provides a natural way to cope with difficulty, temporarily dulling discomfort while strengthening social bonds. In medical settings, humor therapy and laughter exercises have shown promise as complementary pain management approaches. The connection between laughter and pain relief reveals the deep integration of emotional and physical experience, showing that joy isn't separate from the body but works through it, using ancient neurochemical pathways to bring comfort. How do emotions arise? Common sense suggests you see a bear, feel afraid, and then run. But the James Lange theory, proposed over a century ago, reversed this sequence. You see a bear, your body responds with racing heart and tensed muscles, and you interpret these bodily changes as fear. In this view, emotion follows rather than precedes physical response. More recent theories suggest the relationship is more complex and bidirectional. Your brain continuously predicts what your body should be feeling based on context, and emotions emerge from the interaction between these predictions, actual bodily states, and situational interpretation. What's clear is that emotion isn't purely mental. It involves the entire body, changes in heart rate, breathing, muscle tension, hormone levels, all contributing to emotional experience. This explains why changing your physical state through exercise, breathing techniques, or posture can shift your emotional state. It also means emotions are not simply reactions to events, but interpretations, your brain making sense of complex bodily signals in light of context. Two people can have similar physiological arousal but interpret it as excitement or anxiety depending on the situation. This complexity suggests emotions are constructed experiences, built moment by moment from bodily sensations, thoughts, and environmental cues, woven together into feelings that seem simple but rest on remarkably intricate foundations. Familiarity breeds not contempt, but affection. The mere exposure effect describes your tendency to develop preference for things simply through repeated, neutral exposure. The more often you encounter a stimulus, whether a person, song, image, or word, the more you tend to like it, even if you weren't particularly drawn to it initially. This effect works best with neutral or slightly positive stimuli and can occur even when exposure happens below conscious awareness. Images flashed too quickly to consciously register still create preference through repeated exposure. The mere exposure effect likely evolved because familiar things are generally safer than unfamiliar ones. What you've encountered before without harm is probably safe to approach again. This automatic preference for the familiar influences everything from music taste to romantic attraction. Songs often grow on you with repeated listening. People tend to like others they encounter regularly, even without meaningful interaction. Advertisers exploit this effect through repetition, knowing that simply seeing a brand repeatedly increases positive feelings toward it. Understanding this bias helps you recognize that your preferences aren't purely rational choices, but are shaped by simple exposure. What feels like genuine preference may partly reflect familiarity, a cognitive shortcut that usually serves you well but can also be manipulated, making you like what you've simply seen most often. Within about 7 seconds of meeting someone, you've formed a first impression that, fair or not, will influence all subsequent interactions. This rapid judgment happens automatically, drawing on facial features, body language, clothing, and countless other cues to create an overall assessment. These impressions cover trustworthiness, competence, likability, and other key dimensions of social evaluation. Once formed, first impressions are remarkably sticky. Subsequent information tends to be interpreted in ways that confirm rather than contradict initial judgments, a pattern called confirmation bias. The speed and persistence of first impressions reflect evolutionary pressures. Quick assessment of strangers as potential allies or threats had survival value. But this rapid system makes errors, relying on superficial cues and unconscious biases that don't necessarily reflect deeper character. Someone having a bad day might create a negative first impression that doesn't represent their typical self. Physical attractiveness inappropriately influences assessments of unrelated qualities. Despite these limitations, first impressions continue to shape social interactions powerfully. Understanding their formation helps you navigate them more skillfully, both in how you present yourself to others and in remaining open to revising your own quick judgments. That first 7 seconds carries disproportionate weight, but it doesn't have to be permanent if you consciously allow for correction and deeper understanding over time. When you learn that someone has one positive quality, you tend to assume they have other positive qualities as well, even without evidence. This is the halo effect, where one prominent trait, often physical attractiveness, casts a metaphorical glow over all other evaluations. Attractive people are unconsciously perceived as more intelligent, kind, and competent than less attractive people, despite no actual correlation. Similarly, if someone is good at one thing, you're likely to overestimate their abilities in unrelated domains. The halo effect creates systematic bias in many contexts. In job interviews, initially positive impressions lead interviewers to ask easier questions and interpret ambiguous answers favorably. In schools, teachers may grade attractive students more leniently or give well-behaved students benefit of doubt on academic work. The effect works in reverse too. One negative quality can create a horn effect, where everything about a person is viewed more negatively. These biases operate largely unconsciously, making them difficult to counteract despite awareness. The halo effect reveals how much your mind relies on shortcuts and generalizations rather than independent evaluation of separate qualities. It's cognitively efficient to assume consistency, but it creates distortions that can lead to poor judgments and unfair treatment, reminding you that evaluation is never purely objective but always filtered through biases and automatic inferences. You're more likely to help someone when you're in a good mood. Studies have repeatedly shown that positive emotional states increase prosocial behavior, making people more generous, cooperative, and willing to assist others. Even small mood boosts, finding money, receiving a compliment, or experiencing pleasant weather increase helping rates. This happens partly because good moods increase your attention to positive aspects of situations and reduce perceived costs of helping. When you feel good, offering assistance seems less burdensome and the social interaction seems more appealing. Interestingly, sunny weather correlates with increased helping behavior, larger tips, and more positive social interactions. The effect is modest but reliable, showing how environmental factors can subtly influence social behavior through mood. This connection has implications for when you ask for favors or try to motivate pro-social behavior. timing matters. People are more generous after positive experiences. It also suggests that cultivating positive mood isn't just personally beneficial but socially valuable, as your emotional state influences how you treat others. The link between feeling good and doing good creates potential virtuous cycles. Acts of kindness that boost mood can inspire further kindness, rippling through social networks. Your emotional state, shaped by countless small factors, quietly influences your willingness to extend yourself for others. The bystander effect describes how people are less likely to help in emergencies when others are present, each assuming someone else will act. This diffusion of responsibility can be overcome through a simple intervention: direct eye contact. When you make eye contact with a specific person and directly request help, the bystander effect largely dissolves. That person can no longer diffuse responsibility across the crowd because they've been individually selected and recognized. This is why emergency responders are taught to point at specific individuals and give direct commands rather than making general appeals to a crowd. Eye contact creates personal connection and accountability, breaking through the anonymity that allows responsibility diffusion. The power of eye contact extends beyond emergencies. In general social interactions, eye contact signals attention, interest, and engagement. It's among the strongest forms of non-verbal communication, creating moments of connection that feel immediate and significant. Avoiding eye contact, conversely, can signal disinterest, discomfort, or evasion. The eyes, often called windows to the soul, serve as powerful communication channels, establishing connection, conveying emotion, and creating the sense that you're truly seen by another person, breaking through the invisible barriers that often keep people isolated even in crowds. Without realizing it, you constantly mirror the people you interact with, unconsciously matching their gestures, posture, facial expressions, and speech patterns. This automatic mimicry, called the chameleon effect, increases during positive interactions and with people you like. The effect is bi-directional. You mimic those you like, and mimicking someone makes you like them more. When your conversational partner leans forward, you lean forward. When they cross their legs, you might do the same moments later, entirely unconsciously. This synchronized behavior serves important social functions. It signals rapport, attention, and affiliation, helping interactions flow more smoothly. People whose gestures are mimicked report liking their interaction partner more and feeling the interaction went better, even when they don't consciously notice the mimicry. The mechanism likely involves mirror neurons, brain cells that fire both when you perform an action and when you observe someone else performing it. These neurons may create a neural bridge between people, allowing you to internally simulate others' states. While mimicry can be deliberately used to build rapport, forced or exaggerated mirroring feels creepy rather than connecting. Natural, unconscious mimicry works because it's genuine, a spontaneous expression of attention and affiliation, your body naturally synchronizing with those around you. Social rejection hurts, and that's not merely metaphorical. Brain imaging studies show that social exclusion activates some of the same neural regions as physical pain, particularly the anterior cingulate cortex and insula. When people are deliberately left out of a simple ball-tossing game or receive negative social feedback, these pain-related areas become active. This overlap suggests that social pain uses ancient pain circuitry, reflecting how crucial social connection has been throughout human evolution. Being excluded from the group once meant real danger, and your brain treats social rejection as a genuine threat. This neural overlap explains why social wounds can feel as real and painful as physical injuries, and why social support can reduce physical pain perception. The connection runs both ways. Physical pain activators like acetaminophen have been shown in some studies to reduce feelings of social rejection, though this research remains somewhat controversial. What's clear is that your brain doesn't maintain a strict boundary between social and physical suffering. Both signal threat and demand attention, both motivate you to change your situation. Understanding social pain as neurologically real rather than just emotional sensitivity validates the genuine distress of exclusion, bullying, or loss. Recognizing these experiences as hurts the brain processes with the same seriousness as bodily harm. The chameleon effect goes beyond simple mimicry to reveal something fundamental about social connection. When you interact with someone, your nervous systems begin to synchronize. Your speech patterns converge, you adopt similar vocabulary, your breathing may align, Even your heart rates can show coordination during deep conversation. This synchronization happens automatically and mostly unconsciously, creating a kind of physiological resonance between people. The more rapport you feel, the stronger this synchronization becomes, and the synchronization itself strengthens rapport in a reinforcing cycle. This effect has evolutionary roots. Coordination and synchronization would have helped early human groups function cohesively, signaling group membership and facilitating cooperation. Today, this ancient mechanism continues shaping your social world. You naturally synchronize with those you're close to while remaining more independent with strangers or adversaries. The chameleon effect shows that social connection isn't just psychological but profoundly physical, involving coordination across multiple biological systems. When you truly connect with someone, you're not just sharing ideas but synchronizing your very physiology, your bodies moving into a shared rhythm. This reveals the deep embodiment of social life, connections existing not just between minds but between bodies, breathing, moving, and existing in coordinated patterns that create the feeling of genuine togetherness. On average, people speak about 16,000 words per day, though individual variation is enormous. Some people are naturally more talkative, while others are more taciturn. And contrary to stereotype, large-scale studies have found no consistent difference between men and women in average daily word count. The number varies based on personality, occupation, social situation, and mood. Some days you might speak far less, others considerably more. What's interesting is less the specific number than what it reveals about human social nature. Language is your primary tool for social connection, information sharing, and collaborative thinking. That you spend significant portions of each day engaged in verbal communication shows how central social exchange is to human life. Even people who consider themselves introverted or quiet typically use thousands of words daily. The words you speak construct your social reality, maintaining relationships, negotiating meaning, expressing identity, and coordinating action. Speech isn't just information transfer but social bonding. Much of daily conversation serves to maintain connection rather than exchange novel information. Small talk, though often dismissed as meaningless, actually does crucial social work, affirming relationships and creating comfortable spaces for deeper conversation to emerge. Those thousands of daily words are threads weaving the social fabric that surrounds and supports you. You probably overestimate how much others notice about you. The spotlight effect describes your tendency to believe others are paying more attention to your appearance, behavior, and mistakes than they actually are. When you wear an embarrassing shirt or say something awkward, it feels like everyone notices and remembers. In reality, most people are too focused on their own concerns to pay much attention to your minor mishaps. Their spotlight is pointed at themselves, not at you. This effect stems from the basic fact that you're the center of your own experience. You notice everything about yourself, every wardrobe choice, every verbal stumble, so you assume others notice too. But they have their own internal worlds commanding their attention. Research confirms this. People significantly overestimate how much their mistakes or appearance quirks are noticed by others. Understanding the spotlight effect can be liberating. That embarrassing moment you're worried about? Most people didn't notice, and those who did have probably already forgotten it, having moved on to their own concerns. This doesn't mean you're unimportant, but it does mean you can relax a bit, secure in knowing that others are generally not scrutinizing you nearly as much as you fear. The audience you imagine watching your every move is largely illusory, freeing you to worry less about judgment. Conformity, the tendency to align your behavior and opinions with those around you, increases with group size, but only to a point. Research shows that conformity grows as groups expand from one other person to about 4 or 5. Beyond that size, adding more people produces little additional conformity pressure. This pattern appears across cultures and situations, though the baseline level of conformity varies. The effect makes sense. Unanimous agreement among several people sends a strong signal that they might be correct, making you doubt your own divergent perception. But once several people agree, additional agreements add little new information. Whether 5 people or 50 agree against you, the social pressure is essentially the same. This research helps explain how social influence works. Small groups can create powerful conformity pressure, making it difficult to maintain dissenting views. But you don't need to convince everyone to break conformity's hold. Just finding one or two allies who share your view can dramatically reduce pressure to conform. This is why diversity of opinion within groups is so valuable. It makes it easier for individuals to express genuine views rather than simply aligning with perceived consensus. Understanding conformity's dynamics helps you recognize when social pressure may be influencing your judgments and gives you strategies for maintaining independence when it matters. Perfection can be distancing, while small mistakes can make you more likable, a phenomenon called the pratfall effect. When someone who appears highly competent makes a minor blunder, spilling coffee or fumbling words, they often become more appealing rather than less. The mistake humanizes them, making them seem more approachable and relatable. However, this effect has an important caveat. It works primarily for people who are already perceived as competent. For someone whose competence is uncertain, mistakes can confirm negative impressions rather than creating endearing vulnerability. This pattern reveals something important about social perception. People generally don't want perfection in others. It can feel threatening or create social distance. A small flaw makes someone seem more human, more similar to yourself. This is why carefully curated perfect images on social media often create envy rather than connection, while authentic sharing of struggles and mistakes tends to build genuine rapport. The pratfall effect suggests that trying too hard to appear flawless can backfire socially, while allowing your human imperfections to show can actually enhance likability. This doesn't mean deliberately making mistakes, but rather not being afraid of them, recognizing that your occasional stumbles make you more relatable rather than less worthy. Vulnerability, when combined with basic competence, creates connection. You're more easily persuaded by people who are similar to you. This similarity can be demographic, sharing age, ethnicity, or background, or it can be subtler, having similar interests, values, or communication styles. Similarity creates an automatic sense of kinship and trust, making arguments from similar others feel more credible and relevant. Advertisers and salespeople use this principle constantly, trying to establish common ground before making their pitch. When you see yourself reflected in someone else, you're more inclined to trust their judgment and recommendations. This bias towards similar others makes evolutionary sense. People like you likely faced similar challenges and had similar goals, making their experiences more relevant to your own decisions. In modern contexts, this can lead to echo chambers where you primarily encounter opinions that match your own, reinforcing existing beliefs rather than challenging them. The similarity attraction effect extends beyond persuasion to general liking. You tend to form friendships and relationships with people who resemble you in various ways. While this creates comfortable connections, it can also limit your exposure to different perspectives. Recognizing this tendency helps you consciously seek out diverse viewpoints and question whether you're accepting arguments because they're valid or simply because they come from someone you perceive as similar to yourself, making your decision-making more robust. Once you agree to a small request, you become more likely to agree to a larger related request later. This is the foot in the door technique, and it works because of your desire for consistency. After agreeing to the small initial request, you form a self-perception as someone who supports that cause or helps that person. When the larger request comes, refusing would create cognitive dissonance, conflicting with your newly formed self-image. To maintain consistency, you're more likely to agree to the bigger ask. This principle appears throughout daily life. Charities often start with small requests, signing a petition or accepting an awareness ribbon before asking for donations. Salespeople might ask you to test a product before pitching a purchase. In your own behavior, starting with small commitments can help build habits or relationships. Want to start exercising? Begin with 5 minutes rather than committing to an hour. Once you've established yourself as someone who exercises, expanding the commitment feels natural. The technique works because humans have a deep drive for consistency between self-perception and behavior. Small initial actions shape how you see yourself, and that self-perception then guides future choices. Understanding this can help you recognize when others are using the technique on you, and can also help you use gradual commitment to shape your own behavior in desired directions. Loneliness isn't just emotionally painful, it's physically harmful. Research has found that chronic loneliness is as damaging to health as smoking 15 cigarettes a day, affecting cardiovascular function, immune response, and mortality risk. Lonely people experience higher levels of stress hormones, more inflammation, and poorer sleep quality. The effects accumulate over time, making persistent loneliness a serious health concern rather than just a psychological discomfort. This connection makes sense from an evolutionary perspective. For highly social species like humans, isolation meant danger, and your body responds to loneliness as a threat. Importantly, loneliness isn't the same as being alone. You can feel lonely in a crowd if relationships lack depth, and you can feel connected while spending time alone if you have strong relationships overall. What matters is the subjective experience of isolation and lack of meaningful connection. This distinction suggests that addressing loneliness requires quality over quantity in relationships. A few deep connections may matter more than many superficial ones. Understanding loneliness as a health issue, not just an emotional one, emphasizes the importance of social connection for overall well-being. Maintaining and nurturing relationships isn't optional self-care, but fundamental health maintenance. As vital as diet and exercise, your social bonds quite literally helping keep you alive and well. You might expect that doing favors for someone makes them like you more. Surprisingly, the reverse is often true. Doing a favor for someone else can make you like them more. This counterintuitive pattern is called the Benjamin Franklin effect, named after Franklin's observation that asking opponents for small favors turned them into friends. The mechanism involves cognitive dissonance. When you do a favor for someone, your mind asks why you do this. The easiest answer is that you must like them, otherwise why would you help? This self-perception process alters your feelings to align with your actions, resolving potential dissonance. If you help someone, they must be worth helping, therefore you must like them. The effect is stronger when the favor feels voluntary rather than obligated. True choice makes the cognitive shift more powerful. This principle has practical applications. If you want someone to like you, asking them for a small favor, something they can easily do, might work better than offering favors yourself. Their act of helping you leads them to see you more positively. The Benjamin Franklin effect reveals how actions shape attitudes at least as much as attitudes shape actions. Your behaviors don't just express your feelings but actually create them, working backward from what you do to determine how you feel, continuously constructing and reconstructing your relationships through the interpretation of your own choices. Every decision you make depletes a limited mental resource. By day's end, after hundreds or thousands of choices, your decision quality deteriorates, a phenomenon called decision fatigue. You become more impulsive, more likely to avoid decisions by accepting defaults, and less able to carefully evaluate options. This explains why judges grant parole more readily early in the day than late, why you're more likely to make poor food choices in the evening, and why important negotiations are better conducted when everyone is fresh and rested. Decision fatigue is one reason successful people often create strict routines for trivial decisions, wearing the same style of clothes or eating similar meals daily. These routines preserve mental energy for more important choices. The effect highlights a fundamental truth about mental resources. They're finite and renewable. Each decision, even small ones about what to wear or what to have for lunch, draws from the same pool. Once depleted, this resource takes time to replenish, typically requiring rest and especially sleep. Understanding decision fatigue suggests strategies for better choices. Make important decisions early when mental energy is highest. Establish routines for trivial choices. And be aware that difficult decision-making itself is tiring work that requires recovery. Your capacity for good judgment isn't constant, but fluctuates throughout the day, making timing as important as analysis. The first number you encounter in any context can dramatically influence your subsequent judgments, even when that number is completely irrelevant. This is the anchoring effect, one of the most robust biases in human judgment. When estimating anything, whether a fair price, reasonable quantity, or appropriate amount, people latch onto initial values and adjust insufficiently from them. If a car is initially priced at $30,000, you'll likely consider $25,000 a good deal, even if the car's actual value is much lower. Anchors work even when obviously random. In one study, people spun a wheel that landed on random numbers before estimating historical dates. Their estimates were pulled toward the random number they'd seen. Real estate agents, negotiators, and salespeople use anchoring constantly, knowing that whoever sets the first number often shapes the entire discussion. The effect persists despite awareness. Knowing about anchoring doesn't eliminate its influence. The best defense is to generate your own anchor before encountering others, researching fair prices or appropriate ranges independently. Anchoring reveals how suggestible your numerical judgments are, how heavily initial impressions weigh regardless of their source or validity. This bias shows that your mind, rather than objectively evaluating information, tends to accept initial inputs as reference points and make only incremental adjustments, leaving you vulnerable to manipulation through carefully chosen opening numbers. When your actions contradict your beliefs, you experience an uncomfortable tension called cognitive dissonance. Your mind seeks consistency, and this mismatch creates psychological stress that demands resolution. Interestingly, rather than changing behavior to match beliefs, you often change beliefs to match behavior. If you do something that conflicts with your values, you're likely to adjust those values to reduce the discomfort. Someone who considers themselves environmentally conscious but drives a gas-guzzling car might downplay climate change importance rather than change their vehicle choice. This process happens largely unconsciously through motivated reasoning and selective attention to information that justifies your choices. Cognitive dissonance explains many puzzling behaviors: why people defend poor decisions they've already made, why commitment to a cause increases after making sacrifices for it, and why changing minds is so difficult once someone has acted on a belief. The dissonance between "I did this" and "this was wrong" is often resolved by deciding it wasn't actually wrong. Understanding cognitive dissonance helps you recognize when you might be rationalizing rather than reasoning, adjusting your beliefs to justify your actions rather than genuinely evaluating them. It also explains why behavioral change often precedes attitudinal change. Sometimes you need to act differently before you can think differently, your beliefs following your actions into new territory. You've invested hours into a boring movie, so you watch until the end. You've spent years in an unfulfilling relationship, so you stay longer. This is the sunk cost fallacy, continuing an endeavor because of previously invested resources, even when continuation no longer makes sense. Rationally, past investments are gone regardless of future decisions. What matters is whether continuing provides value going forward. But emotionally, abandoning something you've invested in feels like admitting waste, turning a loss into a definitive failure rather than keeping alive the possibility of eventual return. The sunk cost fallacy appears everywhere, in business, relationships, careers, and personal projects. It keeps failing initiatives funded because we've already invested so much. It maintains unhappy situations because leaving would mean admitting the time invested was wasted. The fallacy reveals your mind's difficulty with loss acceptance and your tendency to honor past decisions even when circumstances have changed. Overcoming it requires focusing strictly on future costs and benefits, ignoring what's already gone. Ask not, "How much have I invested?" but "What's the best path forward from here?" This shift is psychologically difficult but practically essential. Your past investments don't obligate your future. Each moment offers a fresh choice about where to direct energy and resources, unbound by what came before except as information about what works and what doesn't. Having options feels empowering, but research on choice suggests the relationship between options and satisfaction is complex. While having some choice is clearly better than none, increasing options beyond a certain point can reduce satisfaction through several mechanisms. More options make decisions harder, increasing doubt about whether you made the best choice. They raise expectations, making you imagine a perfect option and feel disappointed when reality falls short. They increase regret, as you're more aware of attractive alternatives you didn't choose. These effects don't mean choice is bad, but they challenge the assumption that more choice is always better. In complex domains like healthcare plans or retirement investments, overwhelming options can lead to poor decisions or complete avoidance. Simplified choice sets often produce happier outcomes even if they're objectively limiting. This research suggests that sometimes less is more, that constraints can be liberating rather than limiting. When you have fewer options, you spend less energy deciding, have lower expectations, experience less regret, and often feel greater satisfaction with your choice. The paradox of choice reveals that freedom isn't just about having options, but about having manageable options that allow confident decisions without overwhelming complexity or perpetual second-guessing, suggesting that curation and limitation sometimes serve you better than endless possibility. Losing $20 feels considerably worse than finding $20 feels good. This asymmetry, called loss aversion, means losses loom psychologically larger than equivalent gains. Research suggests losses hurt about twice as much as gains feel good, a ratio that appears across cultures and contexts. This bias profoundly affects decision-making, making you overly cautious about potential losses even when the expected value suggests taking risks. You'll work harder to avoid losing money than to gain the same amount. Reject bets that are objectively favorable because potential loss feels too painful. Loss aversion likely evolved because losses often posed greater threats to survival than gains provided benefits. Missing a meal hurts more immediately than extra food helps. This ancient bias shapes modern behavior in sometimes counterproductive ways, keeping you in unsatisfying situations because change risks loss, preventing beneficial risks because you overweight downside possibilities, and making you hold losing investments hoping they'll recover. Understanding loss aversion helps you recognize when fear of loss might be distorting your decisions. Sometimes the rational choice involves accepting potential losses for greater potential gains, but your emotional system resists this logic. Compensating for loss aversion means consciously reframing decisions, focusing on potential gains rather than only losses, and recognizing that your automatic weighting isn't always optimal, especially in contexts very different from ancestral environments where this bias evolved. How do you estimate how common or likely something is? Often, you rely on how easily examples come to mind, a mental shortcut called the availability heuristic. If you can quickly recall instances of something, you judge it as more frequent or probable. This usually works well. Common events are easier to remember, but it creates predictable biases. Vivid, recent or emotionally charged events are more available in memory regardless of their actual frequency, leading you to overestimate their likelihood. This explains why people overestimate risks like plane crashes or shark attacks while underestimating more common dangers like car accidents or heart disease. Dramatic events receive media coverage, making them mentally available even though they're statistically rare. The availability heuristic also explains why personal experience disproportionately shapes risk perception. If something has happened to you or someone close, it feels more likely to happen again. Being aware of this bias helps you seek statistical information rather than relying solely on what springs to mind. Your memory isn't a representative sample of reality, but a curated collection shaped by vividness, emotion, and recency. What's easily recalled isn't necessarily what's most important or most likely, requiring you to question your intuitive probability assessments and seek more objective data when judgments matter, compensating for memory's systematic distortions. Once you hold a belief, you unconsciously seek information that supports it while avoiding or dismissing contradictory evidence. This is confirmation bias, one of the most pervasive thinking errors. You interpret ambiguous information as supporting your views. Remember confirming evidence better than disconfirming evidence, and ask questions designed to produce answers you expect. This bias makes beliefs remarkably resistant to change. You can encounter substantial opposing evidence while feeling increasingly confident you're correct because you're selectively attending to the parts that fit your existing views. Confirmation bias affects everything from political opinions to personal relationships. You notice your partner's flaws when you're upset with them, their virtues when you're feeling loving, the same behavior interpreted differently depending on your prior emotional state. In beliefs about yourself, confirmation bias maintains both positive and negative self-concepts. You see evidence confirming your self-image while missing contradictory data. Combating confirmation bias requires deliberate effort, actively seeking opposing viewpoints, trying to prove yourself wrong rather than right, and considering what evidence would change your mind. This is difficult because confirmation feels like truth-seeking. Finding evidence that fits your view feels like learning rather than bias. Recognizing this tendency doesn't eliminate it, but it can prompt intellectual humility, awareness that your confident beliefs rest partly on selectively gathered evidence, filtered through expectations that shape what you see. Adding a third option can change which of two options you prefer, even when the third option is clearly inferior. This is the decoy effect, and it's used extensively in marketing. Imagine choosing between a small coffee for $2 and a large for $3. Preferences will vary. But add a medium for $2.90, suddenly the large seems like a better deal, and more people choose it. The medium is asymmetrically dominated by the large, worse in every way, making the large appear more valuable by comparison. The decoy effect reveals that preferences aren't absolute but contextual, shaped by the set of available options. You don't have fixed internal values for products or choices, but instead evaluate options relative to each other. Adding irrelevant alternatives can shift decisions by changing the comparison context. Businesses use decoys constantly. The middle pricing tier nobody chooses exists partly to make the expensive options seem more reasonable. Understanding the decoy effect helps you recognize when extra options might be manipulating rather than expanding your choice, prompting you to evaluate alternatives based on your actual needs and values rather than comparative framing. It also reveals something humbling about decision-making. You don't always know what you want independent of context. Your preferences are constructed in the moment through comparison and framing, meaning the same choices presented differently can yield different decisions, your wants themselves shaped by presentation. After an event occurs, you feel like you knew it would happen all along. This is hindsight bias, the tendency to see past events as having been predictable even when they weren't. Once you know an outcome, you unconsciously reconstruct your prior understanding to make that outcome seem inevitable. This creates an illusion of understanding and predictability that distorts learning from experience. You can't accurately remember what you believed before knowing the result, making it difficult to learn which of your predictions were actually accurate. Hindsight bias affects evaluations of decisions. Choices leading to good outcomes seem wise in retrospect, even if they were risky or poorly reasoned at the time, while choices leading to bad outcomes seem obviously foolish, even if they were reasonable given available information. This makes evaluating decision quality difficult. You need to assess the process and information available at decision time, not just the outcome. Hindsight bias also creates overconfidence. If the past seems more predictable than it was, you'll likely overestimate your ability to predict the future. Combating this bias requires conscious effort to remember your actual uncertainty before events unfolded, perhaps by documenting predictions before outcomes are known. Understanding hindsight bias cultivates humility about how much you can truly know in advance and fairer evaluation of past decisions, recognizing that uncertainty was real even if it no longer feels that way. How information is presented dramatically affects your choices, even when the underlying facts are identical. This is the framing effect, and it reveals that decisions depend on description as much as substance. Medical treatment described as having a 90% survival rate is more appealing than one with a 10% mortality rate, despite being identical. Ground beef labeled 90% lean seems better than 10% fat, same product, different frame. Loss frames and gain frames trigger different emotional responses and decision patterns. Losses feel more urgent even when objectively equivalent to foregone gains. Framing effects appear everywhere. Political messages, advertisements, and news coverage all use strategic framing to influence perception. The same policy can seem reasonable or outrageous depending on how it's described. Understanding framing helps you look past presentation to underlying substance, asking what's really being offered rather than just how it's described. It also reveals that objective decision-making is largely illusory. Your choices are inevitably shaped by framing, language, and context. Even neutral presentation is itself a frame. This doesn't mean all framing is manipulation. Sometimes frames highlight genuinely important aspects of situations. But it does mean that recognizing framing effects is essential for thoughtful decision-making, helping you consider multiple perspectives and question whether your reaction stems from the substance of an option or simply from how it was presented to you, the same reality viewed through different linguistic lenses. Most of your decisions aren't consciously deliberated but made automatically by unconscious processes. Throughout each day, you make countless choices about where to look, what to say, how to move, what deserves attention, with minimal conscious involvement. Even for seemingly deliberate decisions, unconscious processing does substantial work before options reach conscious awareness. Your brain evaluates possibilities, applies learned rules, integrates information from multiple sources, and narrows options, presenting to consciousness not all possibilities but a pre-selected set. or sometimes a single strong preference that feels like it simply arose. This doesn't mean you lack agency, but rather that consciousness plays a different role than you might think. Instead of generating decisions from scratch, consciousness often ratifies, adjusts, and contextualizes decisions largely prepared unconsciously. This division of labor is efficient, freeing limited conscious capacity for complex problems while handling routine matters automatically. However, it also means your choices are influenced by factors you don't consciously perceive. Recent experiences, current mood, environmental cues, all shape unconscious processing. Understanding this helps explain why you sometimes act in ways that surprise you, why decisions can feel like they came from nowhere, and why changing behavior often requires working with rather than against automatic processes. Your unconscious isn't an enemy to overcome, but a powerful ally, handling countless tasks that would overwhelm conscious deliberation, though one that benefits from occasional conscious examination and course correction. When you remember an experience, you don't average all moments equally. Instead, you judge the entire experience largely based on its most intense moment, positive or negative, and its ending. This is the peak-end rule, and it means that duration has surprisingly little effect on remembered experience. A longer vacation isn't necessarily remembered as better than a shorter one if the peak and ending are similar. A medical procedure that ends with moderate pain is remembered as worse than a longer procedure that ends with mild pain, even though it involved less total suffering. This pattern has practical implications. Ending experiences on high notes creates lasting positive impressions that outweigh earlier difficulties. Conversely, bad endings can sour memories of otherwise positive experiences. The peak-end rule explains why final impressions matter so much in customer service, performances, and relationships. It also reveals a disconnect between experiencing and remembering selves. Your experiencing self lives through all moments, but your remembering self, which makes most long-term evaluations and decisions, focuses on peaks and endings. This can lead to choices that serve memory better than experience, enduring unpleasant situations for a good ending, or pursuing intense peaks despite overall displeasure. Understanding this rule helps you distinguish between what makes experiences good to live through versus good to remember. Two perspectives that don't always align, each valid but serving different purposes in how you construct and recall your life. Sleep isn't uniform, but progresses through distinct stages in roughly 90-minute cycles throughout the night. REM sleep, characterized by rapid eye movements, occurs primarily during the later portion of each cycle and is when most vivid dreaming happens. During REM, your brain shows high activity resembling waking patterns, but your body experiences muscle atonia, temporary paralysis that prevents you from acting out dreams. This stage appears crucial for emotional processing, memory consolidation, and learning, particularly for complex skills and emotional memories. As night progresses, REM periods lengthen while deep slow-wave sleep decreases. This architecture means the timing of sleep matters, not just duration. Waking after 6 hours costs you disproportionate REM sleep compared to the first 6 hours, potentially impacting emotional regulation and learning. Different sleep stages serve different functions. Slow-wave sleep for physical restoration and declarative memory, REM for emotional processing and procedural learning. The cycling nature of sleep suggests that even brief interruptions can disrupt this carefully orchestrated process, degrading sleep quality beyond just lost time. Understanding sleep architecture emphasizes that sleep is active and structured, not simply rest or unconsciousness, but a precisely organized sequence of processes, each stage contributing uniquely to physical health, mental function, and emotional well-being, making sleep's quality as important as its quantity. After 24 hours without sleep, your cognitive impairment resembles having a blood alcohol level at the legal limit for intoxication. Reaction times slow, attention wanders, judgment deteriorates, and memory formation becomes severely impaired. Sleep deprivation affects the prefrontal cortex particularly strongly, impairing executive functions like planning, impulse control, and complex decision-making. You become more emotional and reactive as connections between the emotional amygdala and regulatory prefrontal cortex weaken. Notably, sleepless people often don't recognize their own impairment, feeling more capable than they actually are. Chronic partial sleep deprivation, getting 6 hours nightly instead of the needed 7 to 9, creates cumulative deficits that approach total sleep deprivation after just 2 weeks. Your performance declines progressively while your subjective sense of sleepiness plateaus, meaning you feel equally tired after 3 days and after 10 days, even though your actual functioning continues deteriorating. This gap between perceived and actual impairment makes sleep deprivation particularly dangerous. Modern culture often treats sleep as optional luxury, but neuroscience reveals it as fundamental necessity. No other intervention restores function once sleep debt accumulates. Your brain requires actual sleep to recover. This understanding frames adequate sleep not as laziness but as essential maintenance, your cognitive abilities depending absolutely on regular, sufficient rest, without which your performance degrades regardless of effort or willpower. The average person spends about 6 years of their life dreaming, though most dreams are forgotten within minutes of waking. Dreams occur during all sleep stages but are most frequent and vivid during REM sleep. Despite feeling longer, most individual dreams last only 5 to 20 minutes. The narrative complexity and emotional intensity of dreams creates an illusion of extended duration, much like how time perception distorts during waking emotional experiences. Dream content tends to draw from recent experiences and persistent concerns, incorporating elements from the day blended with older memories in often bizarre combinations. Dreams may serve multiple functions: processing emotions, consolidating memories, simulating social scenarios, or problem-solving. The exact purpose remains debated, but the universal nature of dreaming across cultures and the severe problems caused by REM sleep deprivation suggest important functions. Some dreams appear to help extinguish emotional responses to difficult experiences, repeatedly exposing you to threatening situations in safe contexts. Others may strengthen relevant memories while allowing irrelevant details to fade. The bizarreness of dreams likely results from the brain's free association without the reality constraints and logical monitoring active during waking. In dreams, your mind explores connections and possibilities unconstrained by physical laws or social expectations, creating experiences that feel profound or nonsensical depending on the dream and your reflection afterward. Messages from the unconscious mind speaking in its own strange symbolic language. Nightmares peak during early childhood, between ages 3 and 6, when they're a normal part of development as children process fears and learn emotional regulation. After childhood, nightmare frequency generally declines, though they increase again during periods of high stress, trauma, or anxiety in any life stage. Nightmares differ from night terrors, which occur during non-REM sleep, involve intense fear and confusion, and aren't usually remembered. Nightmares happen during REM sleep and are typically recalled upon waking, often with vivid detail and lingering emotional resonance. Recurrent nightmares can indicate unprocessed trauma or anxiety disorders and may benefit from therapeutic intervention. Interestingly, imagery rehearsal therapy, where you consciously reimagine nightmare content with different, more positive outcomes while awake, can reduce nightmare frequency and intensity. This suggests nightmares aren't random but represent the brain's attempts to process difficult material, attempts that can be guided and redirected. The content of nightmares often reflects common human fears: being chased, falling, losing control, social humiliation, suggesting that even in sleep your mind grapples with fundamental vulnerabilities. While distressing, occasional nightmares are normal, your sleeping brain working through fears and anxieties, sometimes successfully integrating them, sometimes simply expressing them in vivid, memorable scenarios that carry emotional weight into waking life, demanding attention to concerns you might otherwise ignore. During stage 2 sleep, your brain produces brief bursts of rapid brainwaves called sleep spindles. These spindles, lasting just a second or two, appear to serve multiple functions, including memory consolidation and protecting sleep from external disturbances. Research shows that people who produce more sleep spindles are better able to sleep through noise, the spindles somehow blocking disruptive sensory information from reaching conscious awareness. This suggests your brain actively works to maintain sleep, not just passively continuing unless disturbed, but implementing specific mechanisms to preserve rest. Individual variation in sleep spindle production may explain why some people wake at the slightest sound while others sleep through significant noise. The spindles represent one of many active processes during sleep. Your brain isn't simply offline but engaged in complex activities distinct from waking function. Stage 2, sleep, though lighter than deep slow-wave sleep, occupies about half your total sleep time and appears essential for cognitive function. The discovery of sleep spindles' protective function reinforces that sleep stages serve specific purposes, each contributing uniquely to restful sleep. Your sleeping brain constantly monitors the environment while simultaneously working to maintain unconsciousness, balancing the need to respond to genuine threats against the need for uninterrupted restoration, a delicate equilibrium maintained through specialized neural mechanisms operating throughout the night, beyond your awareness or control. In lucid dreams, you become aware that you're dreaming while the dream continues, sometimes gaining ability to control dream content and actions. About 55% of people report experiencing at least one lucid dream, though spontaneous lucid dreaming is rare for most people. However, lucid dreaming can be learned through techniques like reality testing, regularly checking during waking hours whether you're dreaming, habits that transfer into dreams where reality checks reveal the dreaming state. Other methods include setting intentions before sleep and training dream recall, as remembering dreams is prerequisite for working with them consciously. During lucid dreams, brain activity shows interesting patterns. Areas associated with self-awareness and metacognition become more active than in normal dreams, while the dream state continues. This creates a hybrid state, simultaneously asleep and aware, experiencing vivid sensory content while knowing it's self-generated. Research shows that skills practiced in lucid dreams can transfer to waking performance, though the effects are modest. Beyond practical applications, lucid dreaming offers unique experiences: flying, visiting impossible places, conversing with dream characters, all while conscious it's a dream. This state demonstrates consciousness's flexibility, awareness arising within a state previously considered entirely unconscious, revealing that the boundary between sleeping and waking isn't absolute but admits intermediate states where aspects of both coexist, expanding the possibilities of human consciousness. During sleep, your brain activates a waste clearance system called the glymphatic system. Cerebrospinal fluid flows through brain tissue, flushing out metabolic waste products that accumulated during waking hours, including beta amyloid and tau proteins associated with Alzheimer's disease. This cleaning process occurs primarily during sleep when neurons shrink slightly, expanding interstitial spaces and allowing fluid to flow more freely. The glymphatic system provides a compelling explanation for why sleep is essential. Your brain literally needs offline time to clear cellular debris. This discovery suggests that chronic sleep deprivation might increase dementia risk by allowing toxic proteins to accumulate rather than being cleared nightly. The system highlights sleep's restorative function at the most basic cellular level. During waking hours, neurons work continuously, generating waste that must be removed. Sleep provides the necessary downtime for this maintenance, similar to closing a business temporarily for cleaning. You can't accomplish this cleaning while fully active, just as you can't effectively clean a busy restaurant during service. The glymphatic system reveals sleep as essential biological maintenance, not optional luxury, your brain requiring regular offline periods to maintain health. This understanding reinforces that sleep cannot be indefinitely postponed or reduced without consequence. The waste accumulates, potentially contributing to cognitive decline and neurodegeneration over time, making adequate sleep not just about feeling rested but about long-term brain health. Dreams typically last 5 to 20 minutes in real time, but perceived duration within dreams can vary dramatically. Sometimes dreams feel like they span hours, days, or even longer periods, while others feel compressed and fleeting. This distortion occurs because dream time follows psychological rather than clock time, shaped by narrative structure, emotional intensity, and memory encoding rather than external temporal markers. Without regular sensory input marking time's passage, your dreaming mind constructs duration based on event density and emotional weight rather than actual elapsed minutes. The malleability of dream time demonstrates that temporal experience is actively constructed rather than directly perceived. During waking, multiple systems track time: circadian rhythms, environmental cues, activity patterns, and explicit time checking. In dreams, most of these inputs disappear, leaving time perception to float freely, expanding or contracting based on dream narrative alone. This creates the peculiar experience of living through lengthy dream events, then waking to discover mere minutes passed. The disconnect reveals something fundamental. Experienced duration depends more on how your brain processes events than on how long they objectively take. In both waking and dreaming, your temporal experience is an interpretation, a story your brain tells about the passage of time, based partly on external markers but shaped profoundly by attention, memory, and emotional state, making time itself, as you experience it, a mental construction rather than a direct perception of reality. Your brain generates thousands of distinct thoughts throughout each day, though the exact number is difficult to measure precisely and varies considerably among individuals and across different days. Recent research using advanced techniques to detect when thoughts shift suggests the number might be around 6,000 thoughts daily, far lower than the frequently cited but unsourced claim of 70,000. What counts as a distinct thought versus a continuation remains somewhat arbitrary, making exact quantification challenging. Some thoughts are brief flickers, while others extend into sustained contemplation, further complicating counting. What's perhaps more interesting than the specific number is recognizing the constant stream of mental activity. Your mind rarely rests, continuously generating observations, memories, plans, judgments, and imaginings. Many thoughts are repetitive, recycling familiar concerns and patterns rather than breaking new ground. This mental activity, though sometimes productive, can also create unnecessary stress and rumination. Meditation practices often aim to observe this thought stream without being controlled by it, creating space between stimulus and response. Understanding the volume and repetitive nature of daily thoughts helps you recognize that not every thought requires attention or action. Most thoughts are simply mental noise, bubbles rising to consciousness without deep significance. You can choose which thoughts to engage and which to let pass, rather than treating every mental event as important, learning to distinguish signal from noise in the constant chatter of the mind. True multitasking, simultaneously performing multiple tasks requiring conscious attention, is largely a myth. What you experience as multitasking is actually rapid task switching, your attention alternating between activities rather than processing them simultaneously. Each switch carries a cost: time to disengage from one task, reorient to another, and reload relevant information into working memory. These switching costs accumulate, reducing overall productivity by up to 40% compared to sequential single tasking. The reduction isn't just about time lost, but also quality degradation. Divided attention produces more errors and shallower processing. The belief that you're effectively multitasking often stems from the feeling of busyness and engagement, which creates an illusion of productivity. In reality, you're performing both tasks less well than if approached separately. Certain combinations work better than others. Pairing an automatic task, like walking, with a demanding one, like conversation, succeeds because automaticity requires minimal attention. But pairing two attention-demanding tasks, like writing emails while listening to a presentation, degrades both. Your attention is a limited resource, not infinitely divisible. Understanding multitasking's costs helps you recognize when focus serves you better than switching, when single tasking, though feeling slower, actually produces better and faster results. The modern pressure to multitask often backfires, creating busy inefficiency rather than productive activity. The placebo effect typically requires deception. You must believe you're receiving active treatment for the effect to work. Surprisingly, research has found that placebos can still produce benefits even when people know they're taking inactive pills, a phenomenon called open-label placebo. In studies where participants were explicitly told they were receiving placebos but that placebos might trigger the body's own healing mechanisms through expectation and conditioning, many experienced real symptom improvement, particularly for conditions involving subjective symptoms like pain, fatigue, or mood. This counterintuitive finding suggests the placebo effect operates through multiple mechanisms, not just deceptive belief, but also ritual, expectation, and the therapeutic context of receiving treatment. The act of taking a pill, expecting attention to your body, and participating in healing rituals may activate physiological responses even without belief in biochemical efficacy. This opens fascinating possibilities for ethical placebo use in medicine, harnessing mind-body connections without deception. It also reveals the profound influence of context, expectation, and ritual on physical experience. Your body responds not just to chemical interventions, but to the entire healing situation, the provider's attention, your own expectations, the ritual of treatment. Mind and body intertwine more deeply than simple cause and effect, with consciousness capable of influencing physiology through pathways we're only beginning to understand, even when you know the influence is self-generated. Brain freeze, that sudden sharp pain when eating something very cold, occurs because rapid cooling of the palate triggers protective responses in blood vessels. The cold causes blood vessels to constrict quickly, then dilate as they warm up. This rapid change, particularly in the anterior cerebral artery, sends pain signals that are referred to your forehead, creating the characteristic ice cream headache. The pain serves as a warning to slow consumption of cold substances, protecting your brain from rapid temperature changes that could potentially affect function. The referred nature of brain freeze, pain felt in your forehead from changes in your mouth, demonstrates how pain localization can be imprecise. Your brain constructs pain location from nerve signals and sometimes gets confused, placing sensation away from its actual source. Brain freeze typically lasts less than a minute as blood vessels return to normal. You can prevent or reduce it by eating cold foods more slowly or warming the palate with your tongue when pain begins. This common experience reveals the body's sensitivity to rapid changes and its sometimes excessive caution. The discomfort far outlasts any real danger. It's a reminder that pain isn't always proportional to actual harm, but serves as a signaling system that errs toward overreaction. Better to warn of minor threats than miss a major one, even if it means occasional false alarms that hurt without corresponding danger. Your brain represents only about 2% of your body weight, yet consumes approximately 20% of your total energy. This disproportionate energy demand reflects the intensive computational work of maintaining consciousness, processing sensory information, controlling movement, and regulating bodily functions. Neurons constantly maintain electrical potentials across their membranes, requiring continuous energy expenditure even at rest. Mental effort further increases energy consumption, though less dramatically than you might expect. Focused cognitive work increases brain energy use only modestly above resting levels. This high baseline energy cost explains why the brain has evolved such remarkable efficiency, packing immense computational power into a compact, energy-constrained package. It also explains why blood flow to the brain is so carefully regulated, and why even brief disruptions can cause serious problems. Neurons have limited energy reserves and depend on constant fresh delivery. The brain's energy hunger shaped human evolution, requiring high-quality diets and long childhoods for brain development. In daily life, it means your brain competes with other organs for resources. One reason why hunger impairs cognition and why glucose depletion affects mental performance. Your thinking, though seeming purely mental, is deeply physical, each thought supported by continuous energy expenditure, making consciousness expensive in biological terms. Your brain's 3-pound universe requiring a fifth of your body's power to maintain its constant activity. For decades, neuroscience maintained that you're born with all the neurons you'll ever have, with brain development involving only connection refinement and pruning. This view has been overturned by evidence of neurogenesis, the birth of new neurons, continuing throughout life in at least some brain regions. The hippocampus, crucial for memory formation, generates new neurons even in elderly adults. This ongoing neurogenesis appears important for learning and memory, with new neurons integrating into existing circuits and contributing to cognitive function. Interestingly, neurogenesis is influenced by behavior and environment. Exercise, learning, stress reduction, and enriched environments all promote new neuron generation, while chronic stress and isolation suppress it. This suggests you have some influence over your brain's structural development throughout life. The discovery of adult neurogenesis fundamentally changed understanding of brain plasticity, revealing that the brain remains more dynamic and adaptable than previously thought. While most neurons are indeed formed early in life, the capacity for generating new cells persists, offering potential for recovery after injury and for maintaining cognitive function during aging. This ongoing birth of neurons, though limited in scope, means your brain isn't a static structure but a living organ continuously regenerating, capable of renewal and adaptation throughout your entire lifespan. Old patterns capable of being supplemented by new cells, bringing fresh perspectives into ancient networks. When your mind isn't focused on external tasks, it doesn't simply idle but activates a specific network called the default mode network. This system becomes active during rest, daydreaming, and mind-wandering, engaging in self-referential thought, autobiographical memory, social cognition, and imagination. The default mode network appears to construct your sense of self, maintain your life narrative, and simulate social interactions and future scenarios. Rather than being wasted time, mind-wandering may serve important functions in planning, self-understanding, and creativity. Interestingly, the default mode network typically deactivates during focused external tasks, suggesting a toggle between inward and outward attention. Inability to properly deactivate this network during task performance correlates with attention problems and reduced efficiency. Meditation practices often involve observing default mode activity without engagement, creating awareness of typically unconscious mental habits. The discovery of this network revealed that rest isn't emptiness, but a specific active state with its own functions. Your brain doesn't turn off when you stop focusing externally, but shifts to internal processing, working through memories, plans, and self-concepts. This suggests that both focused work and unfocused rest serve essential cognitive functions, each enabling different types of thinking. The constant internal narrative you experience, that sense of existing as a continuous self through time, emerges partly from default mode network activity, your brain telling yourself the story of who you are. Brain training games and apps promise to improve general cognitive function through targeted practice of specific skills. While you can certainly improve at the specific tasks you practice, research on transfer effects, whether training on one task improves performance on different tasks or in real-world situations, has been disappointing. Most studies find minimal transfer beyond the trained task itself. Getting better at memory games makes you better at those specific games but doesn't substantially improve general memory function or reduce dementia risk as initially hoped. This limited transfer occurs because skill is often domain-specific. Your brain optimizes for the particular demands of practiced activities without necessarily building general capacities that apply broadly. The most reliable cognitive benefits come from activities with real complexity and meaning, learning languages, musical instruments, or complex skills involving multiple cognitive systems simultaneously. Physical exercise, particularly aerobic exercise, shows more robust cognitive benefits than computerized brain training. This doesn't mean mental exercise is worthless. Challenging yourself cognitively is valuable, but specific brain training apps likely aren't magic bullets for cognitive enhancement. Real-world learning, physical activity, social engagement, and novel experiences appear more effective for maintaining cognitive health. Your brain improves what you specifically practice in contexts that matter to you, meaning the best brain training is simply living an engaged, varied, challenging life rather than isolated skill drills divorced from meaningful application. Learning and regularly using a second language appears to provide cognitive benefits, particularly in executive function and attention control. Perhaps most remarkably, bilingual individuals show dementia symptoms on average 4 to 5 years later than monolingual individuals, even when brain pathology is similar. This delay represents substantial benefit, years of maintained cognitive function despite underlying neurodegeneration. The mechanism likely involves cognitive reserve, the brain's resilience to damage built through challenging mental activity. Constantly managing two languages, inhibiting one while using the other and switching between them, exercises executive control systems. This lifelong mental workout appears to strengthen these systems, making them more resistant to age-related decline. The benefit isn't about knowing two languages per se, but about the constant mental exercise of managing them. Bilingual individuals don't escape dementia, but when symptoms finally appear, underlying brain damage is typically more advanced than in monolingual patients with similar symptoms, suggesting the enhanced cognitive reserve compensates for deterioration longer. This research highlights that how you use your brain throughout life affects its late-life resilience. Mental challenge, particularly sustained over decades, builds structural and functional reserves that protect against decline. While learning a language in middle or late life still offers benefits, The most dramatic effects come from lifelong bilingualism, suggesting that cognitive reserve accumulates over time, every year of mental engagement adding to the buffer that protects you when age begins taking its toll. The left hemisphere controls the right side of your body and vice versa, a crossover occurring in the brain stem. This lateralization extends beyond motor control to cognitive functions, though popularized left brain/right brain distinctions are oversimplified. Language processing occurs primarily in the left hemisphere for most people, while spatial processing often shows right hemisphere preference. However, both hemispheres contribute to virtually all tasks, with extensive communication through the corpus callosum ensuring integrated function despite some specialization. The popular notion of left brain logical people and right brain creative people lacks scientific support. Creativity, logic, language, and spatial skills all engage both hemispheres in complex, coordinated ways. Individual differences in cognition don't reflect differential hemisphere use, but rather differences in how entire brain networks function together. Lateralization likely evolved for efficiency. Avoiding duplication of function in both hemispheres allows specialization and more total capacity. But the brain operates as an integrated system, with few functions truly confined to one hemisphere. Understanding accurate lateralization helps dispel myths about brain function while appreciating real specialization. Your brain isn't divided into opposing sides competing for control, but is a unified organ with some regional specialization serving overall integrated function, both hemispheres working together constantly through millions of connecting fibers, creating the seamless experience of unified consciousness despite underlying distributed processing across specialized regions working in continuous coordination. While childhood and adolescence involve dramatic brain development, maturation continues into the mid-20s. The prefrontal cortex, responsible for executive functions like planning, impulse control, risk assessment, and considering long-term consequences, is among the last regions to fully mature. This extended development explains some typical adolescent and young adult behavior, increased risk-taking, greater susceptibility to peer influence, and sometimes poor long-term decision-making. The brain has adult-like capacity for many functions by late adolescence, but continues refining judgment and self-regulation into the 20s. This developmental timeline has implications for education, legal responsibility, and understanding youth behavior. Adolescent risk-taking isn't simply poor judgment, but reflects a brain still building the circuitry for mature decision-making while also experiencing heightened reward sensitivity. The combination creates a developmental period characterized by exploration and learning, but also vulnerability to poor decisions. Understanding this extended development encourages patience and support rather than judgment of young people, recognizing they're working with brains still under construction. It also suggests that experiences during late adolescence and early adulthood continue shaping brain development significantly. The choices you make and experiences you have into your mid-20s literally influence your brain's final architectural form, making this period not just a time of exploration but of fundamental neural sculpting, your experiences helping determine the adult brain you'll carry through the rest of life. Regular meditation practice produces measurable changes in brain structure. Studies using MRI have found that long-term meditators show increased gray matter density in regions associated with attention, sensory processing, and emotional regulation, particularly in the hippocampus and areas involved in self-awareness and compassion. The prefrontal cortex, important for attention and executive control, can show increased thickness, while the amygdala, the brain's fear and stress center, may show reduced size in regular meditators, suggesting decreased reactivity to stress and threat. These structural changes correlate with functional differences. Meditators often show improved attention, reduced mind wandering, better emotional regulation, and lower stress reactivity. The changes aren't instantaneous but accumulate with practice, with some effects visible after just 8 weeks of daily meditation. This demonstrates neuroplasticity in action, mental training reshaping brain structure just as physical training reshapes muscles. Different meditation types may produce different effects. Attention-focused meditation strengthening attention networks, while compassion-focused meditation enhances regions involved in empathy. The research suggests meditation isn't merely relaxation but a form of mental training producing lasting neural changes. Your brain's physical form responds to how you use it. Regular meditation literally restructuring neural tissue in ways that support the very qualities you're cultivating, making temporary states of calm or focus into stable traits embedded in your brain's architecture itself, carried forward as structural gifts from disciplined practice. Imagining performing an action activates many of the same brain regions as actually performing it. Mental practice, vividly visualizing yourself executing a skill, produces measurable improvements in performance, though not as large as physical practice. Athletes have long used visualization to supplement training, and research confirms its effectiveness. When you mentally rehearse, your motor cortex activates in patterns similar to actual execution, strengthening the neural pathways controlling those movements without physical movement occurring. Mental practice works best when combined with physical practice rather than replacing it entirely. It's particularly valuable when physical practice is impossible due to injury, access limitations, or between physical sessions to supplement actual training. The technique also applies to non-motor skills. Mentally rehearsing presentations, social interactions, or problem-solving can improve actual performance. This reveals that learning is fundamentally neural rather than purely physical, about building and strengthening brain patterns rather than training muscles or body parts. Your muscles don't store motor skills, your brain does, and mental rehearsal can access and strengthen those brain patterns directly. This means practice continues even when you're not physically engaged, imagination serving as a form of training. The overlap between mental and physical action suggests that action itself is partly mental, each physical movement beginning as neural activation that can be strengthened through thought alone, making mind and body not separate but deeply intertwined in how you learn and perform. Personality traits show considerable stability after age 30, with people's characteristic patterns of thinking, feeling, and behaving remaining relatively consistent across decades. The big five traits, openness, conscientiousness, extroversion, agreeableness, and neuroticism, show decreasing changeability through young adulthood, reaching substantial stability by the 30s. This doesn't mean personality becomes fixed or unchangeable, but rather that baseline tendencies stabilize, requiring more intentional effort to modify compared to earlier developmental periods when personality remains more fluid and responsive to experience. However, personality can still change throughout life, particularly in response to major life events, deliberate therapeutic work, or sustained environmental shifts. People can become more conscientious, less neurotic, or more open through intentional effort and experience, but changes tend to be gradual rather than sudden. Understanding personality stability helps set realistic expectations about yourself and others, recognizing that core patterns are real and persistent while remaining open to meaningful change. The stability after 30 reflects the consolidation of years of experience into characteristic patterns, your personality becoming the story your life has told you about who you are. But the story isn't finished, each day adding new material that can gradually shift the narrative. You're neither completely fixed nor infinitely malleable, but somewhere between, carrying forward tendencies built over decades while retaining capacity for continued growth and adaptation throughout life's remaining chapters. Despite widespread belief that birth order shapes personality, with firstborns supposedly more responsible and youngest children more rebellious, large-scale scientific studies involving hundreds of thousands of participants have found essentially no relationship between birth order and personality traits. Earlier, smaller studies sometimes found effects, but these haven't replicated in more rigorous research controlling for confounding factors. When you carefully measure personality traits and control for family size and other variables, birth order explains virtually none of the variance in how people differ. This doesn't mean birth order has no effects whatsoever. Parents may treat children differently based on birth order, and siblings certainly experience different family configurations, firstborns having exclusive parental attention initially while later children never do. But these experiences don't consistently translate into measurable personality differences across large populations. Individual families may show birth order effects, but they don't generalize into reliable patterns. This finding illustrates how intuitions about behavior can be misleading. Birth order feels like it should matter, and casual observation seems to confirm expectations. But rigorous evidence reveals the relationship is far weaker than folk psychology suggests. Understanding this helps you avoid unfounded assumptions about people based on family position and recognizes that personality forms through countless influences, with birth order contributing far less than commonly believed, your character shaped more by genetics, individual experiences, and choices than by whether you arrived first, middle, or last in your family's sequence. While personality shows stability, particularly after age 30, it's not immutable. Research demonstrates that personality can change significantly over decades and that intentional effort can accelerate change. People can become more conscientious, less neurotic, more agreeable, or shift on any personality dimension through sustained effort, appropriate experiences, and sometimes therapeutic intervention. The key is consistency. Personality change requires repeated practice of new patterns until they become habitual. Not just one-time decisions, but ongoing commitment to different ways of being. Therapy, particularly cognitive behavioral approaches, can facilitate personality change by helping you identify and modify thought patterns and behaviors that maintain personality traits. Life experiences also shape personality. People who enter committed relationships often become more conscientious and agreeable, while those experiencing major stress may become more neurotic temporarily or permanently depending on how they process the experience. Understanding that personality can change offers hope that you're not locked into patterns you dislike. However, it also requires realistic expectations. Change is possible but gradual, demanding sustained effort over months or years. Your personality is like a river. It has direction and momentum built over time, capable of changing course but not instantly, requiring consistent pressure applied over time to shift the flow. You can shape yourself deliberately, but the shaping is work, requiring patience, persistence, and recognition that you're working against established patterns, possible but never effortless. Your character, both inheritance and ongoing creation. Self-compassion, treating yourself with the same kindness and understanding you'd offer a good friend, predicts mental health and well-being better than self-esteem alone. While high self-esteem involves positive self-evaluation, it can be fragile, requiring constant validation and threatened by failure. Self-compassion involves recognizing that imperfection and struggle are part of the shared human experience, responding to your own difficulties with care rather than harsh judgment. Research shows self-compassionate people experience less anxiety and depression, recover better from setbacks, and maintain more stable well-being across varied circumstances. The difference lies in how you relate to difficulty. Self-esteem asks, "Am I good enough?" and depends on positive answers. Self-compassion asks, "How can I support myself through this?" and applies regardless of success or failure. When you fail, self-esteem suffers while self-compassion offers comfort. Contrary to concerns that self-compassion might promote complacency, research finds the opposite. Self-compassionate people show greater motivation for self-improvement, but from desire to care for themselves rather than prove their worth. They can acknowledge mistakes without defensiveness and learn from failures without shame spiraling. Cultivating self-compassion involves recognizing common humanity in your struggles, treating yourself kindly rather than harshly, and maintaining balanced awareness of difficulties without exaggerating them. This shift from self-judgment to self-care creates a secure foundation for mental health independent of external validation, replacing the fragile tower of self-esteem with the stable ground of unconditional self-kindness, supporting you through both success and failure. Your sense of identity forms partly through how you imagine others perceive you. This concept, called the looking glass self, suggests that you develop self-understanding through social interaction, using others' reactions as mirrors reflecting who you are. You imagine how you appear to others, imagine their judgment of that appearance, and develop self-feelings based on these imagined judgments. This process operates largely unconsciously, shaping your self-concept through countless social interactions from childhood forward. The looking glass self means identity is social rather than purely individual. Who you believe yourself to be emerges through relationship and interaction. This explains why social rejection feels threatening to identity itself, not just painful emotionally, but destabilizing to your sense of self. It also means self-concept can shift based on social context. You may feel confident and capable in familiar settings, but uncertain in new social environments where others' perceptions are unclear. Understanding this process helps you recognize that your self-image is construction rather than discovery. built through social interaction rather than revealing a pre-existing true self. This awareness can be liberating. Negative self-concepts formed through past interactions can be revised through new relationships, offering different reflections. Your sense of who you are remains responsive to your social world throughout life, continuously being negotiated through interaction, making identity not a fixed core but an ongoing conversation between your self-perception and your understanding of how others see you, forever emerging from that dialogue. Empathy isn't a single capacity but involves distinct systems. Cognitive empathy, understanding others' perspectives and mental states, operates through different brain networks than emotional empathy, feeling others' emotions. You can possess one without the other, understanding what someone feels without sharing the feeling, or catching others' emotions without clearly understanding their perspective. Most people have both capacities to varying degrees, but they develop differently, respond to different experiences, and can be selectively impaired by various conditions. Cognitive empathy involves theory of mind networks in areas like the temporal parietal junction and medial prefrontal cortex, regions that allow you to represent others' mental states. Emotional empathy involves systems like the anterior insular and anterior cingulate cortex, areas processing your own emotions that activate when observing others' feelings. Some conditions affect these differently. Autism spectrum conditions may involve reduced cognitive empathy, while emotional empathy remains intact, while psychopathy may involve impaired emotional empathy despite intact or even enhanced cognitive empathy, allowing understanding of others' minds without emotional resonance. Recognizing this distinction helps clarify that empathy is complex, involving multiple capacities that can vary independently. True empathy ideally combines both, understanding others' perspectives while also resonating with their emotions, thinking and feeling together, creating the fullest connection where you both know their mind and share their heart, two forms of reaching across the gap between separate consciousnesses. Most people experience an internal monologue, a running verbal commentary accompanying their thoughts. However, not everyone thinks this way. Some people report thinking primarily in images, abstract concepts, or feelings without verbal narration. This variation in inner experience, only recently receiving research attention, suggests that the subjective experience of thinking varies considerably across individuals. Those without internal monologue often report surprise that others hear words in their heads, while those with robust internal monologue struggle to imagine thinking without it. The prevalence of each thinking style remains uncertain, with estimates varying widely depending on how the question is asked. Some research suggests that even those reporting no internal monologue may have verbal thoughts in certain situations, suggesting variation in how prominent verbal thinking is rather than absolute presence or absence. The differences may relate to how working memory functions and how the brain represents information. Despite these variations in phenomenology, people without internal monologue don't show cognitive deficits. They think, plan, and reason effectively using different internal processes. This diversity in mental experience reminds you that consciousness isn't uniform. Even basic aspects of what thinking feels like vary across people. Your internal experience, which feels universal and obvious to you, may be quite different from others' experience, each mind creating its own private landscape that others can never fully access, making the inner life of even those closest to you fundamentally unknowable, permanently private, despite all efforts at sharing. Your sense of self feels continuous and stable, but it's constructed moment by moment from memories, current experiences, and anticipated futures. This construction, drawing on the past to create present identity while projecting forward into imagined tomorrows, means the self is inherently fluid rather than fixed. Memory research reveals that autobiographical memories, the stories you tell about your life that form your identity, change over time, being edited and reinterpreted based on current perspective. The person you remember being at 20 may differ from who you actually were, your current self reshaping past self to create narrative coherence. This reconstruction isn't necessarily inaccurate or dishonest, but reflects how identity works as a story that must make sense in the present while accounting for the past. Yourself is the main character in this ongoing narrative, and like any story's protagonist, you're understood through how the narrative frames you. When new experiences shift your perspective, the entire story refracts through new meaning, past events taking on different significance. This fluid construction means there's no unchanging essential self to discover beneath experience, but rather a self continuously created through experience. You're both the author and the protagonist of your life story, writing it while living it, each moment both expression of who you are and creation of who you're becoming, identity forever emerging from the interplay of memory, experience, and imagination, a dance of past, present, and future creating the ever-shifting constellation you call yourself. And so our journey through 100 truths about the mind comes to rest. We've wandered together through memory and dreams, through the social currents that connect us and the hidden biases that shape our choices. We've explored how your brain constructs reality, how emotions ripple through your body, and how consciousness emerges from the intricate dance of billions of neurons, each one a small light contributing to the vast illumination of awareness. What we've really discovered tonight is not just facts about psychology, but something more profound. The recognition that you are both the observer and the observed, the knower and the known. Your mind studying itself, consciousness turning its attention inward, finding they're not answers but deeper mysteries. Each discovery opening new questions about this strange, beautiful experience of being aware. If you've enjoyed this quiet journey into the landscape of the mind, consider liking this video and subscribing for more nighttime explorations of science, psychology, and the natural world. Share your thoughts and reflections in the comments below. I'm always grateful to hear which ideas resonated with you or sparked new questions. Thank you for spending this time exploring the beautiful strangeness of your own mind. Sleep well, and good night.